There is a sound in the room right now, not the ocean, something closer than that. The refrigerator doing its overnight work, or the ventilation pushing air through the walls in passages you have never thought about and will probably never see. It is the kind of sound you only notice when everything else has gone quiet. And noticing it does not change it. It was there before you heard it. It will be there after you fall asleep. It is just the room, being the room, doing whatever rooms do when no one is paying attention. That is where this starts, not with the ocean, not yet. With you in this room, in the specific weight of your body, against whatever is holding you up right now. A mattress, a couch, a pillow arranged in that particular way you have spent years perfecting without ever consciously deciding to perfect it. The body knows where it wants to be. The shoulders settle. The spine finds its compromise between comfort and architecture. The hands rest wherever they have landed, and unless something is actively wrong, the body stops reporting. It just breathes. It just rests. It just exists in the specific volume of this room without needing to know the dimensions. You know this room. Not in the way you know a fact, something you could recite on a test. You know it the way your hand knows the light switch in the dark, the way your feet know the path to the bathroom at 3 a.m. without your eyes needing to open all the way. It is knowledge that lives in the muscles, in the memory of repeated motion, in the body's quiet catalogue of distances and surfaces, and the particular way sound behaves in this specific space. You could navigate this room blind. You probably have. That kind of knowledge, the bodily kind, the kind that does not require language or measurement, comes from being inside something long enough that the inside becomes invisible. You stop seeing the walls, you stop registering the ceiling height. The room becomes a feeling rather than a place, and the feeling is simply home, or at least familiar, which is close enough. Now consider a different kind of inside. The planet you are lying on is, by surface area, mostly not land. This is a fact you have probably encountered before, and it probably did not stay with you, because facts about the Earth's surface tend to slide off the mind the way water slides off a window. You see them for a moment, and then they are gone, replaced by something closer, something with more immediate weight. But stay with it for a second. The oceans cover roughly 71% of the Earth's surface. Not half, not most, 71%. If you could peel the planet like a fruit and lay the skin flat, nearly 3/4 of it would be water. The land you live on, all the continents, all the cities, all the roads and buildings and fields and mountains and deserts, all of it fits in the remaining 29%. You are, in the most literal geographic sense, living on the minority surface of a water planet. The ocean is also old. Not old in the way a building is old, or a city or a civilization. Old in the way that only geological things are old. The oceans have existed in some form for roughly 4 billion years. The water that fills them today is largely the same water that has been cycling through the Earth's hydrological systems since the planet's early history. Some of it may have arrived on comets. Some of it was released from a volcanic outgassing as the young Earth cooled. However it arrived, it has been here for a very long time. The ocean is older than any living thing, older than any fossil, older than the continents in their current arrangement. The Atlantic Ocean did not exist 200 million years ago. The continents were joined. Pangaea sat like a single mass on a planet whose water surrounded it entirely. One ocean, one land mass, and then the land broke apart and the water flowed into the gaps, and the ocean basins we know today took shape over tens of millions of years, slowly, the way geological things happen, at the pace of continents. You have felt the ocean, if you have ever been to a coast, not the deep ocean, not the abyssal zones or the trenches, but the edge of it, the place where the water meets the land, the feeling of sand shifting under your feet as a wave retreats, the specific cold of ocean water around your ankles, a cold that is different from the cold of fresh water, denser somehow, with more weight to it, because salt water is in fact denser than fresh water, and the body registers that difference even if the mind does not name it. The taste of salt on your lips after a wave catches you off guard. The sound of it, which is unlike any other sound, a continuous layered rhythmic roar that the brain classifies as white noise, but that is actually the sum of millions of individual waves, breaking at slightly different times and in slightly different ways along a stretch of coastline. The ocean sounds like one thing. It is actually an enormous number of things happening simultaneously, close enough together that the ear blends them into a single texture. That edge, the shore, is where the known meets the unknown. The land behind you is mapped, measured, photographed, documented. The water in front of you, past the breakers, past the continental shelf, descending into the deep, is mostly not. The transition happens at the waterline. One step forward and you are ankle deep in the most poorly understood feature of your planet. 2 steps and the water is at your knees. A few more and you are swimming, and beneath you the floor drops away, and the water darkens, and the world you know ends and the world you do not know begins, and the boundary between them is as thin as the surface of the ocean itself. And here is the part that takes longer to absorb. As of the most recent data, announced on World Hydrography Day in 2025 by the Seabed 2030 project, a global collaboration between the Nippon Foundation and the General Bathymetric Chart of the Oceans, only 27.3% of the ocean floor has been mapped to modern high-resolution standards. When that same project launched in 2017, the number was 6%. 6, meaning that 8 years ago, 94% of the floor of the dominant feature of the planet you live on had never been properly surveyed. 27% is progress. It represents over 94 million square kilometres of bathymetric data, an area that keeps growing as research vessels and autonomous instruments comb the seabed with sonar. But it still means that roughly 73% of the ocean floor, right now, tonight, while you are lying in this room, remains unmapped in any meaningful detail. There is a comparison that gets repeated often, and I want to use it carefully, because it sounds like the kind of thing someone says to be dramatic rather than accurate. But it is accurate. We have better maps of the surface of Mars than we do of our own ocean floor. Mars has been globally mapped at roughly 20 meters per pixel by orbiting spacecraft. The ocean floor, for most of its extent, has only been estimated from satellite gravity data, which can detect features larger than about 3 miles across, but misses everything smaller. Entire underwater mountains, called seamounts, are missing from our maps. In February 2024, the Schmidt Ocean Institute discovered 4 previously unknown seamounts during a transit between Costa Rica and Chile. The largest of them covered 450 square kilometers and stood over 2,600 meters tall. That is a mountain 5 times the height of one World Trade Center, sitting on the ocean floor. And nobody knew it was there until a research vessel happened to pass over it and check. This is not a metaphor for something. This is the actual state of human knowledge about the largest feature of the planet. The ocean is right here. It is the dominant thing. And we have mapped a little more than a quarter of its floor, which means that the majority of the surface of this planet, the actual physical ground beneath the water, is less known to us than the surface of another planet entirely. What does it mean to live on a world whose main feature you have barely looked at? Not because it is hidden, not because it is far away, not because seeing it requires exotic instruments that only a handful of people can operate. The ocean is right there. You can drive to it in most countries. You can stand at its edge and watch it move. You can put your feet in it and feel the pull of something that has been pulling at shorelines for longer than any living thing has existed to notice. But the floor of it, the actual bottom, the topography that sits beneath all that water is mostly unknown. Not unknown the way the interior of a black hole is unknown, something that may be permanently beyond the reach of observation. Unknown. The way the contents of a room you have never entered are unknown. The door is right there. It is not locked. You just have not opened it very far yet. I keep thinking about this in terms of the room you are in right now. You know this room. You know its edges, its surfaces, its sounds. You have been inside it long enough that the inside has become invisible to you in the way that all familiar interiors become invisible. But imagine that the room extended somehow beyond the walls. Imagine that behind the wall to your left, the space continued and continued and continued, dark and unmapped, for a distance that dwarfed the room, you know. And imagine that you had lived your entire life in the small lit portion, knowing that the rest was there, knowing that it was enormous, and never quite getting around to looking at it carefully. That is roughly the situation. The land is the lit room, the ocean is the rest, and the rest is roughly 2.5 times larger than the part you know. There is a specific quality to that kind of not knowing. It is not ignorance in the careless sense. It is not a failure of curiosity. Mapping the ocean floor is genuinely difficult. Water is opaque to the electromagnetic radiation that satellites use to map land surfaces. You cannot photograph the ocean floor from space, the way you can photograph a mountain range. You need sound. You need sonar. You need ships moving slowly over the surface, bouncing acoustic pulses off the bottom and measuring what comes back. It is painstaking, expensive, and slow. A single research vessel mapping a single transect of ocean can take weeks to cover a strip that a satellite could image on land in seconds. The difficulty is real. The ocean is deep, and depth is expensive, but the result of that difficulty is a planet that does not know itself, a world where the most prominent feature of the surface remains, in its majority, unseen. Not unseen by human eyes, which is a different and less interesting claim, unseen by any instrument. The acoustic signals have not been sent, the echoes have not been received, the data does not exist, and until it does, the floor of the ocean is, in the most literal sense, a blank, a guess, a low-resolution estimate based on the way gravity tugs at the surface of the water from below. Tonight, while the room does its quiet work around you, the ocean floor is sitting in its darkness, holding its topography in confidence. Mountains no one has measured, canyons no one has named, ridges and plains and features that have no human description, because no human instrument has touched them yet. The 27% we have mapped has already produced discoveries that rewrote what we thought we knew. 4 seamounts in a single transit. Over 100 new species in a single expedition off Chile in early 2024. The largest known deep-sea coral reef habitat, spanning over 6.4 million acres off the southeast coast of the United States, characterized only recently through the Seabed 2030 mapping effort. That is 27%. The rest is still waiting, or do not imagine it. Not tonight. Just let the number sit where it is, a quiet fact about the planet you are resting on, and let it be what it is without needing to be more. The ocean does not need your attention to continue being unknown. It has been unknown for the entirety of human history. It will be incrementally less unknown tomorrow, and the day after, and the year after. The mapping is ongoing. The sonar is running. The data is accumulating. But the gap between what is known and what is there is still enormous. And the enormity is not a problem to solve tonight. It is just a texture, a quality of the world you happen to live on, a fact that sits alongside the weight of your body and the hum of the refrigerator and the particular darkness outside the window. All of it real, all of it present, none of it asking anything of you. There is a place in the ocean where the floor drops away in a manner that has no equivalent on dry land. Not a canyon, not a valley, not a gorge cut by a river over millions of years. Something deeper than the word deep was built to describe. A wound in the crust of the earth where one tectonic plate is diving beneath another, dragging the ocean floor down into the mantle, creating a trench so far below the surface that the pressure at the bottom would crush nearly anything humans have ever built. That is the next thing. That is what is waiting somewhere in the dark past this thought. The Mariana Trench sits in the western Pacific Ocean, east of the Mariana Islands, roughly 200 miles southwest of Guam. If you have a globe or a map in your mind, find the Philippines, move east, past the small scattered islands that trail into the Pacific like a sentence that did not quite finish. The trench is there, a crescent-shaped depression in the Earth's crust, roughly 1,580 miles long and averaging 43 miles wide. It was formed, and is still being formed by a process called subduction, where the Pacific Plate, one of the great slabs of rock that make up the Earth's outer shell, is diving beneath the smaller Mariana Plate. The heavier plate slides under the lighter one and descends into the mantle, and the place where it bends downward is the trench, a fold in the skin of the planet, a crease where the Earth is slowly swallowing itself. At the southern end of this trench is a place called the Challenger Deep. It is the deepest known point on the surface of the Earth. The word surface is doing something strange in that sentence, because the Challenger Deep is not a surface in any way the body understands. It is nearly 11 kilometers below sea level. A 2021 study published in Deep Sea Research placed its depth at 10,935 meters, plus or minus 6 meters, at a 95% confidence level, converted to feet. That is roughly 35,876 feet. Converted to something the body might be able to feel, that is about 7 miles straight down through water. 7 miles. You could drive 7 miles in a few minutes on a highway. You could walk 7 miles in a couple of hours on flat ground. You could see 7 miles across a clear landscape, just barely, if the terrain allowed it. 7 miles is a distance the body can hold. It is a distance the mind can picture without breaking. But 7 miles straight down through water, through darkness, through increasing pressure, through cold that never changes and light that never arrives, that is a different kind of 7 miles. That is a distance that changes what it means as you move through it. If you took Mount Everest, the tallest thing on land at 29,026 feet, and turned it upside down and placed it at the bottom of the Challenger Deep, the peak of Everest would still be more than a mile underwater. More than 7,000 feet of ocean would remain between the top of the mountain and the surface. The mountain would fit inside the trench with room to spare, and above the submerged summit, the water would just continue, unbroken, giving no sign of what was underneath. That is the scale of this. The name comes from a ship. The HMS Challenger, a British Royal Navy corvette, sailed the world between 1872 and 1876 on what is considered the first major scientific expedition devoted entirely to oceanography. Using a weighted sounding rope, a method that seems almost comically primitive from a modern perspective, the Challenger crew measured the depth of the trench in 1875 and recorded a figure of 4,475 fathoms, about 5 miles, about 8,184 meters. They were close, but the technology was blunt. It would take another 75 years before a second ship, the HMS Challenger II, returned to the same region in 1951 with echo-sounding equipment and measured a depth of nearly 7 miles. The deepest spot took the name Challenger Deep, a quiet tribute across nearly a century to the ship that first dropped a rope into the darkness and waited to see how long it took to reach the bottom. The pressure at the bottom of the Challenger Deep is approximately 1,086 bar. That number probably means nothing to you in isolation, so here is what it translates to. Roughly 8 tons per square inch, roughly the equivalent of 50 jumbo jets stacked on top of a single person. The water column above the deepest point weighs, per unit area, more than 1,000 times the standard atmospheric pressure you are experiencing right now, lying in your room at sea level, with approximately 10 meters of atmosphere above you. At the bottom of the Challenger Deep, you would not be crushed slowly. You would be compressed so rapidly and completely that the word crushed would not have time to apply. You have felt a version of this, a very small, very gentle, very survivable version. If you have ever dived to the bottom of a swimming pool, even a shallow one, you have felt the pressure against your eardrums. That slight squeeze, that inward push, is the weight of a few feet of water pressing on the membranes of your inner ear. The body notices it immediately because the ear is sensitive and the change is sudden. Now hold that sensation in your mind and understand that for every 33 feet of depth you add, the pressure increases by 1 full atmosphere. At the bottom of the Challenger Deep, you would be experiencing over 1,000 atmospheres. The sensation you felt at the bottom of the pool, multiplied by a factor so large that the comparison becomes absurd. And yet things live there. But before we get to the living things, stay with the descent for a moment longer, because the journey from the surface of the ocean to the bottom of the Challenger Deep is not a single uniform experience. It is a passage through distinct layers of the ocean, each one with its own character, its own conditions, its own quality of light and cold and pressure. The ocean has zones, the way the atmosphere has layers, and each zone is a different world. The first zone is the epipelagic, the sunlight zone. It extends from the surface down to about 660 feet, roughly 200 meters. This is the ocean, you know. This is the ocean of beaches and snorkeling and surface dives, and the blue-green water of vacation photographs. Sunlight penetrates here. Photosynthesis occurs. The plankton that form the base of the marine food web live and multiply here. If you have ever swum in the ocean, you have been in the epipelagic zone. It is warm, or at least warmer than what lies below. It is bright, or at least lit. It is the ocean's public face, the part it shows to anyone standing on the shore. Below the sunlight zone is the mesopelagic, the twilight zone, 660 feet to roughly 3,300 feet, or about 1,000 meters. Light still reaches here, but not enough for photosynthesis. The world becomes dim, blue-grey, then darker. The temperature drops. The creatures you encounter here are adapted to low light. Many of them have oversized eyes, trying to capture the last photons that make it this deep. Many of them are bioluminescent, carrying their own light in a world where the sun's light is fading out. The twilight zone is a transition, a place between the lit world and the dark world, and it has a specific quality of halfway that the body might understand. It is like the moment between waking and sleeping, when you are neither fully in one state nor the other. The ocean at this depth is in that moment, permanently. Below the twilight zone is the bathypelagic, the midnight zone, 3,300 feet to roughly 13,000 feet, no sunlight at all, total darkness, interrupted only by the bioluminescent flashes of organisms producing their own light. The temperature hovers just above freezing. The pressure is building, already hundreds of times what you feel at the surface. Food is scarce. The organisms that live here survive on what falls from above. The marine snow, the slow, constant rain of dead organic matter drifting down from the sunlit world. Flakes of dead plankton, fragments of dead fish, the fecal pellets of creatures living at shallower depths. The midnight zone feeds on the waste products of the world above it. It is a place that subsists on what the rest of the ocean discards. Below the midnight zone is the abyssal pelagic, the abyssal zone, 13,000 feet to roughly 20,000 feet. The word abyss comes from the Greek abyssos, meaning bottomless. The name feels appropriate. The conditions here are extreme in a quiet, relentless way. Near freezing temperatures, enormous pressure, complete, permanent darkness. Very little food, very few organisms. The ones that live here tend to be small, slow-moving, energy-efficient. They cannot afford to waste calories. Everything in the abyss operates on a tight energy budget, and the organisms that succeed are the ones that have found ways to do more with less. And below the abyss, below 20,000 feet, is the Hadal zone, named after Hades, the Greek god of the underworld. The Hadal zone exists only in the ocean's trenches, the deep, narrow gashes where tectonic plates converge and one plate dives beneath the other. The Mariana Trench is the deepest of them. The Tonga Trench, the Kuril-Kamchatka Trench, the Philippine Trench, the Puerto Rico Trench. These are the deepest places on Earth, and the Hadal zone is their domain. Fewer people have been to the Hadal Zone than have been to space. It is one of the least explored habitats on the planet, and the organisms that live there are among the least understood. To descend from the surface to the bottom of the Challenger Deep is to pass through all of these zones in sequence, from the sunlit, warm, familiar surface, through the dimming twilight, into the midnight, through the abyss, and finally into the underworld itself. Each transition marks a change in the temperature, in pressure, in light, in the types of organisms present, in the fundamental conditions of existence. It is a vertical journey through environments as different from each other as a tropical rainforest is from a polar desert, except that the distance between them is measured in miles of water rather than the thousands of miles of land. The ocean stacks its biomes vertically, and the stacking is compressed. 7 miles of depth contain more environmental variation than 7,000 miles of latitude on land. The descent takes hours, even in a modern submersible. There is nothing to see for much of it. After the first few hundred meters, the light fades. After 1,000 meters, it is gone entirely. The submersible's external lights illuminate a small sphere of water around the vessel, and beyond that sphere is black. Absolute black. Not the black of a room with the lights off, where a crack under the door or a glowing clock face or the faint luminescence of a phone screen provides some reference point. The black of a place where photons do not arrive. The black of a world that has never known the sun. The submersible descends through this black for hours, the only interruption being the occasional flash of a bioluminescent organism startled by the light, a momentary spark of blue or green in the infinite dark, and then gone. When Picard and Walsh reached the bottom in 1960, they looked through the porthole and saw the sediment of the ocean floor, the accumulated fallout of millions of years of marine snow, compacted into a soft light-coloured ooze, and in that ooze something was moving. This is the part that resists easy absorption, because the mind has a model of the deep ocean that is mostly wrong. The model says the deep ocean is empty, dark, cold, lifeless, still, a desert underwater. And for a long time science agreed. The assumption was that below a certain depth, life simply could not persist. The pressure was too great, the temperature too close to freezing, the food supply too scarce. Nothing should be able to survive there, and therefore nothing did. That assumption collapsed slowly, and then all at once. In 1960, on January 23rd, 2 men descended to the bottom of the Challenger Deep for the first time. Jacques Picard, a Swiss oceanographer, and Don Walsh, an officer in the United States Navy, climbed into a vessel called the Trieste, a type of free-diving submersible called a bathyscaphe, and sank. The descent took nearly 5 hours. When they reached the bottom, at a depth they estimated at roughly 35,800 feet, they looked out through the small porthole into the darkness, and they saw on the very floor of the deepest place on Earth a flatfish, something alive, something with a body and eyes and fins, lying on the sediment at the bottom of the world, in pressure that should have made it impossible. They saw it for only a moment before the sediment their landing had disturbed clouded the view, but it was there. Scientists later questioned whether what Picard and Walsh saw was actually a fish or a type of sea cucumber, a holothurian, one of those translucent, boneless creatures that drift along the abyssal floor like living ghosts. The debate has never been fully resolved. At those pressures, calcium cannot exist in solid form except in solution, which means that vertebrate bones would literally dissolve. No bones, no fish. Or so the logic went. But nature has a long history of proving logic wrong when it comes to the question of where life can and cannot persist. 52 years later, in 2012, the filmmaker James Cameron descended to the Challenger Deep in a submersible called the Deep Sea Challenger, a vessel he had personally helped design. He reached a depth of 35,787 feet, and set a world record for the deepest solo dive. In 2019, explorer Victor Vescovo went even deeper, reaching 35,853 feet. Vescovo, when he reached the bottom, reported seeing something that no one had expected to find at the deepest point on the planet: a plastic bag. And candy wrappers, human garbage at the floor of the Mariana Trench, in a place where fewer than 30 people have ever been. That image is worth sitting with for a moment, not as a cause for outrage, because outrage is a daytime emotion that does not belong in whatever quiet you are building tonight, but as a fact about the relationship between human civilization and the ocean. We cannot send people to the deepest point on Earth with any regularity. We have barely mapped the floor. We do not understand the ecosystems that exist there, but our trash has arrived ahead of us. The plastic bag at the bottom of the Challenger Deep is not a symbol. It is a literal object sitting on literal sediment, at a literal depth of 7 miles, in literal darkness, in literal pressure that would kill any unprotected human in a fraction of a second. The bag got there without any of the engineering or courage that it took to send a person to the same place. What has been found alive at these depths, in the years since Pickard and Walsh first looked through the porthole, is stranger than what most people expect. Amphipods, which are small shrimp-like crustaceans, thrive in the Hadal zone, the name given to ocean depths below 6,000 meters, or roughly 20,000 feet. The zone is named after Hades, the Greek god of the underworld. That name feels earned. Translucent sea cucumbers drift along the bottom. Foraminifera, single-celled organisms with soft shells, exist at the very deepest points. More than 400 species of Foraminifera have been identified in the Challenger Deep alone. In 2024, researchers aboard the Chinese submersible Finduje, which translates to striver, descended into the Mariana Trench 23 times and discovered the deepest colony of worms and mollusks ever observed, at depths ranging from roughly 8,200 feet to 31,000 feet. In 2023, a separate expedition collected a virus from the trench that is believed to be the deepest bacteriophage ever found. Life at these depths is not an exception. It is a rule that science did not know about until it went looking. The snailfish is perhaps the most remarkable resident. A translucent, scaleless fish from the Liparidae family. It has been found swimming at depths of nearly 27,000 feet, or roughly 8,200 meters. Its skeleton is made of cartilage rather than bone, which allows it to withstand the crushing pressure that would dissolve calcium-based structures. It does not look like a fish in any way you would recognize. It looks like something the deep ocean invented from scratch, something designed for a world that surface life was never meant to visit. And the trench is not just deep. It is geologically active in ways that surface geography does not prepare you for. Near the Mariana Trench, there are hydrothermal vents where superheated water, laden with minerals from the Earth's interior, erupts from the seafloor at temperatures that can exceed 300 degrees Celsius. There is a pool of molten sulfur in the trench that has not been observed anywhere else on the planet. There are mud volcanoes. There are shimmering pools of liquid carbon dioxide, trapped in depressions on the ocean floor. The Mariana Trench is not a static scar. It is an active boundary between tectonic plates, a place where the Earth is doing its deep geological work in real time, rearranging itself at the pace of fingernail growth over millions of years, in total darkness, under pressure that defies the imagination. And we have been there, in person, fewer times than we have sent humans to space. Fewer than 30 people have reached the bottom of the Challenger Deep. Over 7,000 people have summited Everest. We know our highest point far better than our lowest one. The deepest place on the planet is also one of the least visited, least understood, least observed places in the entire solar system that we have the physical ability to reach. The trench does not care about this. The trench is indifferent to observation. The amphipods and foraminifera and snailfish and worms and the single plastic bag are all doing what they do regardless of whether anyone is watching. The hydrothermal vents are venting. The tectonic plates are moving. The pressure is pressing. It is all happening right now, tonight, while you lie in this room and the house settles and the darkness outside the window does its ordinary work. 7 miles down in the Pacific, in the dark, the deepest place on Earth is being the deepest place on Earth, and it will continue being that long after anyone alive tonight has stopped being anything at all. There is something restful about that if you let it be. Not the trench itself, which is not restful in any physical sense, but the scale of it, the sheer duration and patience of geological time. The trench has been forming for millions of years. The organisms at the bottom have been adapting for millions of years. The water above has been pressing down for as long as there has been water. None of it is in a hurry. None of it is anxious. None of it has anywhere else to be. The trench is just sitting in the Pacific, being deep, being dark, being patient, in the way that only geological structures can be patient, which is to say not patient at all, because patience requires the experience of waiting, and the trench does not experience anything. It just persists. That is a different thing and possibly a more useful one to think about when you are trying to rest. The trench is quiet, or at least that is what we assumed for a very long time. The deep ocean was supposed to be silent. No light, no sound, no movement except the slow drift of particles falling from above. The marine snow that feeds the abyssal ecosystems, a gentle rain of organic matter descending through miles of water to the bottom. Quiet, still. A place where silence was the default condition. Then we started listening, and the ocean was not quiet at all. It had been making sounds the entire time, sounds that travelled vast distances through the water column, sounds that no one had ever heard before, because no one had ever put a microphone deep enough to hear them. That is what is coming next. The sounds the ocean makes when it thinks no one is listening. In 1997, in the South Pacific Ocean, a network of underwater microphones called hydrophones, operated by the National Oceanic and Atmospheric Administration's Pacific Marine Environmental Laboratory, recorded something that nobody could explain. The hydrophones were not new. The network had originally been built during the Cold War as part of the United States Navy's sound surveillance system, designed to detect Soviet submarines moving through the deep ocean. After the Cold War ended, the technology was repurposed for science. NOAA used the hydrophones to monitor underwater seismicity, to track the movements of marine mammals, to listen for the cracking and groaning of ice near the poles. The instruments were extraordinarily sensitive. They could pick up sounds travelling through thousands of kilometres of ocean, carried by a layer of water called the SOFAR channel, the sound fixing and ranging channel, where the combination of temperature and pressure creates conditions that allow sound to travel enormous distances with very little loss of energy. A sound produced in the SOFAR channel can propagate across an entire ocean basin. The channel is the ocean's own communication network, a natural acoustic highway that has been carrying signals for as long as there has been water deep enough to form it. In the summer of 1997, this network picked up a sound unlike anything the researchers had heard before. It was ultra-low frequency, well below the range of human hearing. It was extraordinarily loud, loud enough to be detected by hydrophones more than 5,000 kilometers apart. And it had a distinctive acoustic profile. When the recording was analysed, the sound rose rapidly in frequency over about 1 minute, a pattern that looked, on the spectrogram, very much like a biological vocalization, like a call, like a living thing. They named it the bloop. The name is not glamorous. It sounds like a Saturday morning cartoon sound effect. But the bloop was not a cartoon. It was a real sound, detected by real instruments at a real location in the South Pacific, and its source was unknown. The approximate origin was triangulated to a point at roughly 50 degrees south latitude and 100 degrees west longitude. That location, if you look it up, is one of the most remote spots on the planet. It sits in open ocean, west of the southern tip of South America, in the general vicinity of Point Nemo, the point in the ocean farthest from any land in any direction. There is nothing there, no island, no shipping lane, no known geological feature that would produce a sound of this type, just water, all the way to the horizon in every direction, and then more water. The bloop's acoustic profile was the source of the early fascination. NOAA's Dr. Christopher Fox, who was among the first to analyse the recording, noted in interviews over the following years that the sound's rapid frequency variation resembled the patterns found in biological vocalizations, the kinds of sounds that marine animals make. But there was a critical problem with that interpretation. The bloop was several times louder than the loudest known biological sound producer on Earth, the blue whale. If the bloop were being made by a living creature, that creature would have to be far larger than anything science had ever documented. Estimates varied, but some suggested the animal would need to be more than 250 feet long to produce a sound of that amplitude. The largest blue whales ever measured were around 100 feet. The bloop would require something 2.5 times bigger. The internet, predictably, lost its mind. The bloop became one of the most discussed marine mysteries of the late 1990s and early 2000s. Theories proliferated. A new species of megafauna, something impossibly large living in the deep Pacific. A surviving population of some ancient marine reptile. An unknown geological phenomenon. Some people noticed that the coordinates of the bloop's origin were not far from the fictional location of Aurelia, the sunken city from H.P. Lovecraft's stories, where the ancient cosmic entity Cthulhu was said to sleep. That detail alone was enough to cement the bloop in internet mythology for decades. The truth, when it arrived, was less dramatic but more interesting than the mythology suggests. Between 2005 and 2010, NOAA's Pacific Marine Environmental Laboratory deployed additional hydrophones closer to Antarctica to monitor underwater volcanoes and earthquakes in the Southern Ocean. What they found, over 5 years of careful acoustic surveys in the Bransfield Strait and Drake Passage, was that the dominant source of natural sound in the Southern Ocean was ice. Ice breaking, ice cracking, ice calving, which is the process by which chunks of glacier break off and fall into the ocean. And the acoustic signatures of these ice events, when analysed on spectrograms, looked remarkably similar to the bloop. In 2012, NOAA researchers, led by oceanographer Robert Ziak, made it official. The bloop was consistent with the sounds generated by a large-scale cryoseism, which is the technical term for an icequake, a massive fracture event in the Antarctic ice, an iceberg breaking free from a glacier with enough force to send a low-frequency shockwave through thousands of kilometres of ocean water, amplified and carried by the SOFAR channel to the hydrophones in the equatorial Pacific. The mystery was solved. The bloop was ice-breaking. But here is the part that does not get enough attention, and I want to sit with it for a moment rather than rushing past it. The reason the bloop sounded biological, the reason millions of people heard the recording and thought it sounded like a living creature calling from the deep, is because of how it was played back. The original recording was at ultra-low frequency, far below what human ears can detect. To make it audible, Noah sped it up by a factor of 16. At 16 times normal speed, the sound is compressed into a range human ears can hear, and the frequency variations that characterize the icequake sound, when sped up, bear a striking resemblance to animal vocalizations. The bloop sounded like a creature because of how it was translated for human consumption. At its actual speed, played in real time, the bloop sounds like thunder, like a deep rumbling geological event, like ice doing what ice does under tremendous stress. The myth persists because the sped-up version reached the public first. People heard a sound that their brains interpreted as a living call from the deep, and that interpretation lodged itself in the imagination more firmly than the subsequent correction. The bloop is, in a sense, a story about the gap between what the ocean actually produces and what human perception makes of it when the signal has been distorted by the very act of making it audible. The bloop was not the only mysterious sound the hydrophones recorded. NOAA's acoustic monitoring program has catalogued several. There is Julia, a sound recorded on March 1st, 1999, lasting about 2 minutes and 43 seconds, loud enough to be heard across the entire equatorial Pacific hydrophone array. NOAA attributed it to a large iceberg that had run aground off Antarctica. There is the Slow Down, recorded on May 19th, 1997, a sound that gradually decreased in frequency over about 7 minutes, also attributed to ice interaction with the seabed. There is the Sea Train, recorded on March the 5th, 1997, a sound that rises to a steady frequency and holds it. The most likely origin, according to NOAA, is a very large iceberg grounded in the Ross Sea near Cape Adare, a region known for generating strong acoustic signals from ice activity. And then there is the Upsweep. The Upsweep is different from the others, and it deserves its own moment because it remains at this point genuinely not fully explained. It is a sound that consists of a long train of narrow-band upsweeping tones, each lasting several seconds. The NOAA has been recording it since August 1991, when the Pacific Marine Environmental Laboratory first began operating its hydrophone array. The upsweep was already there when they turned the microphones on. It did not begin. It was already ongoing. The source level is high enough to be detected throughout the Pacific. The sound appears to be seasonal, generally reaching peaks in spring and autumn, but it is not clear whether this seasonal pattern reflects changes in the source itself, whatever the source is, or changes in the acoustic propagation environment of the ocean that make the sound more or less detectable at different times of year. NOAA has suggested that the sound may originate from volcanic activity on the seafloor, specifically from the interaction between seawater and hot rock at an active undersea volcanic vent, but this explanation has not been definitively confirmed. The upsweep continues. It has been going on for over 3 decades, at minimum, and possibly much longer. We just were not listening before 1991. Think about that for a moment. The ocean has been making sounds, powerful sounds, sounds that travel across entire ocean basins, for as long as there has been an ocean. The SOFAR channel has been carrying those signals for hundreds of millions of years. The geological processes that produce them, the ice quakes, the volcanic eruptions, the tectonic movements, the calving of glaciers, all of these things have been generating acoustic energy that propagates through the water column at roughly 1,500 meters per second, roughly 4.5 times faster than sound travels through air. The ocean has been full of sound for its entire existence, and we only started eavesdropping in earnest in the 1990s. There are other sounds in the ocean that have nothing to do with geology. Blue whales produce calls that can travel hundreds of miles through the SOFAR channel. Fin whales produce a rhythmic pulsing call at 20 Hz, so low that it was initially mistaken for a submarine or a geological event. Sperm whales produce clicks so loud, up to 230 decibels, that they are among the most powerful sounds made by any animal alive. These sounds have been filling the ocean for millions of years, a vast acoustic landscape that predates not just human civilization, but human existence entirely. And overlaid on top of all of that, increasingly, is the sound of human activity, ship engines, sonar, seismic surveys for oil and gas exploration, underwater construction. The noise floor of the ocean has been rising steadily for decades, and the consequences for marine life, particularly for species that rely on sound for communication, navigation, and finding mates, are only beginning to be understood. The ocean is not quiet. It never was. It is a world saturated with sound, layered and complex, where geological events speak in frequencies too low for human ears, where whales sing across hundreds of miles of water, where ice fractures with enough force to be detected on the other side of the planet, and where human noise is now becoming louder than many of the natural signals. The silence we imagined was never there. We just had not yet built the instruments to hear what was always happening. There is a specific quality to the SOFAR channel that is worth understanding, not because the physics is complicated, but because what it means is strange. Sound travels through water at roughly 1,500 meters per second, about 4.5 times faster than through air. But the speed of sound in water is not constant. It varies with temperature, with salinity, and most importantly, with pressure. Near the surface the water is warm, and sound travels relatively fast. As you descend, the water gets colder, and the sound speed decreases. But at a certain depth, the pressure effect takes over. Pressure increases with depth, and higher pressure increases the speed of sound. So there is a minimum, a depth at which the sound speed is at its lowest, typically somewhere between 700 and 1,200 meters below the surface. This minimum forms a channel, a natural waveguide. Sounds produced at or near this depth get trapped. They cannot escape upward because the increasing temperature above bends the sound waves back down. They cannot escape downward because the increasing pressure below bends them back up. The sound bounces between these boundaries, zigzagging through the ocean, losing almost no energy as it travels. A single sound event in the SOFAR channel can cross an entire ocean basin and still be detectable, thousands of miles away. This is how the bloop was heard by hydrophones over 5,000 kilometers apart. This is how whale songs can be detected across entire oceans. The SOFAR channel is the ocean's long-distance telephone line, and it has been operating for as long as the physical conditions that create it have existed, which is to say for a very long time. Everything that makes sound in the deep ocean, whether it is ice breaking or tectonic plates shifting or a whale calling for a mate, feeds its signal into this channel, and the channel carries it faithfully across distances that would attenuate any airborne sound to nothing. The whale sounds deserve their own moment. The blue whale, the largest animal to have ever existed on Earth, produces calls at frequencies as low as 10 to 20 hertz. These are infrasonically low, below the range of human hearing. The calls are produced in the deep layers of the ocean, where the SOFAR channel can carry them, and they propagate for hundreds of miles. Individual blue whale calls have been tracked across entire ocean basins. What the calls communicate is not fully understood. They may be mating calls, they may be navigational signals, they may carry information about food sources or ocean conditions. The honest answer is that we do not know what blue whales are saying to each other across hundreds of miles of water. The fin whale, the second largest animal on Earth, produces a characteristic call at 20 hertz, a deep rhythmic pulse that repeats at regular intervals. It is so low and so regular that when it was first detected by military hydrophones during the Cold War, analysts initially classified it as a man-made signal, possibly a Soviet sonar system. It was not. It was a whale doing what whales have presumably been doing for millions of years, producing a sound that human technology could not distinguish from a machine. Sperm whales produce clicks, not gentle, quiet clicks, explosive bursts of sound that can reach 230 decibels, making them one of the loudest animals on Earth. The clicks are used for echolocation, a biological sonar system that allows the sperm whale to navigate and hunt in the total darkness of the deep ocean. Each click is a pulse of sound that travels outward from the whale's enormous head, bounces off whatever is in its path and returns. From the returning echo, the whale builds an acoustic image of its surroundings. The sperm whale sees with sound. It perceives the deep ocean not as darkness, but as an acoustic landscape, a three-dimensional map of pressure waves and echoes that it has been reading since before it was born. And over all of these natural sounds, increasingly, there is the sound of us. Ship propellers, engine noise, seismic air guns used in oil and gas exploration, military sonar. The cumulative effect of commercial shipping alone has increased the ambient noise level of the ocean by an estimated factor of 10 over the past 50 years. For species that rely on sound to communicate, to navigate, to find food, and to detect predators, this rising noise floor is not an abstraction. It is an existential pressure. A whale trying to communicate across hundreds of miles of ocean through an increasingly noisy medium is like a person trying to have a conversation in a room where the background noise keeps getting louder. At some point the signal is lost in the noise. At some point the call does not reach the listener. And at that point, whatever information the call was carrying, mating readiness, location, food availability, danger, fails to arrive. The long-term consequences of ocean noise pollution on marine ecosystems are still being studied, and the picture is not yet complete. But what is clear is that the ocean's acoustic environment, which has been relatively stable for millions of years, is changing rapidly, and the organisms that evolved to operate in the quieter ocean of the past are now living in a louder one. Tonight, in whatever ocean is nearest to where you are lying right now, there are sounds moving through the water, low-frequency vibrations from the Earth's crust, the clicks and songs of marine mammals, the groan of ice in the polar regions, carried thousands of miles through the SOFAR channel, the hum of ship engines, the slow, unresolved upsweep that has been cycling through the Pacific since at least 1991, and probably longer without anyone knowing why. None of this is audible to you. None of it reaches this room. The ocean sounds travel beautifully through water and stop almost completely at the interface between water and air. The two acoustic worlds, the airborne and the submerged, barely overlap. You are living in one. The ocean is living in the other. Both are full of sound. Neither hears the other without instruments designed to bridge the gap. That gap, the difference between what the ocean contains and what reaches the shore, is a kind of silence in itself. Not the absence of sound, but the absence of transmission. The ocean is roaring, singing, cracking, humming, and clicking, all of it, all the time, and the beach you stand on hears only the waves. Everything deeper is a secret that requires a hydrophone to overhear. There is one more sound in the ocean that belongs in this part of the night's thinking, not because it is mysterious in the same way the bloop or the upsweep is mysterious, but because it carries a different kind of weight, a weight that the other sounds do not. Since 1989, the United States Navy and later NOAA have been tracking a whale call at a frequency of approximately 52 Hz. This is unusual. Blue whale calls are typically between 10 and 39 Hz. Fin whale calls centre around 20 Hz. A call at 52 Hz sits above the range of any known whale species. The call has been detected in the North Pacific, moving through the ocean on a migratory pattern consistent with a baleen whale, but at a frequency that no other recorded whale matches. The animal producing the call has been nicknamed the 52 Hz whale, or sometimes by the media and the public, the loneliest whale in the world. The name comes from the assumption, which may or may not be correct, that because the 52 Hz whale calls at a frequency above the range of other whales, its calls go unheard by potential mates or companions. It is calling, the logic goes, and nobody is answering because nobody can hear it. It is speaking a language that is close to the language of its species, but not quite close enough. It is communicating into a void. Whether this interpretation is accurate is a matter of scientific debate. Some researchers have pointed out that 52 Hz is not so far outside the range of known whale species that it would necessarily be inaudible. Others have suggested that the 52 Hz whale may be a hybrid, the offspring of two different whale species, producing a call that reflects its mixed parentage. Still others have noted that whale hearing is not perfectly understood, and that the assumption that other whales cannot hear the 52 Hz call may be wrong. What is known is that the signal has been detected consistently for over 3 decades. Whatever is producing it is real. It is alive as of the most recent detections, and it is travelling the North Pacific on a path that suggests a solitary existence. Whether the solitude is a consequence of the frequency, or merely a coincidence of tracking and observation, is not settled. But the 52 Hz whale has captured the human imagination in a way that few other ocean phenomena have, not because it is the most scientifically significant mystery in the ocean, which it is not, but because it resonates with something in the human experience of loneliness, of calling out and not being heard, of existing at a frequency that does not quite match the world around you. I am not going to push that analogy any further than it can hold. The 52 Hertz whale is a whale. Its experience, whatever it is not a human experience translated into whale form, but the resonance is there, and it is honest rather than forced, and it is part of why the ocean sounds occupy a different place in the imagination than, say, the ocean's geology or the ocean's chemistry. Sounds are emotional. They enter the body through the ear and they produce responses that the rational mind does not always control. The sound of the 52 Hertz whale, when you hear the recordings even sped up and processed for human consumption, has a quality of solitary persistence that does not require anthropomorphism to register. It is a call. It is repeated. It moves through the Pacific, and if nothing else hears it, the hydrophones do. The ocean's acoustic landscape, taken as a whole, is not a single sound but a layering. Geological sounds at the very lowest frequencies, the groaning of tectonic plates, the cracking of ice, the eruption of submarine volcanoes. Biological sounds in the middle range, the songs and clicks and calls of whales and dolphins and shrimp and fish, thousands of species, producing sound for thousands of different purposes, and increasingly anthropogenic sounds at frequencies and amplitudes that cut across both. The thrum of engines, the pulse of sonar, the crack of seismic air guns searching for oil beneath the seafloor. All of these sounds travel through the same water. All of them interact, interfere, mask each other, combine. The ocean's soundscape is as complex as any soundscape on land, more complex in many ways because water is a more efficient sound conductor than air, and sounds that would dissipate in meters in air can persist for thousands of kilometers in water. The ocean is an acoustic world of extraordinary richness, and we have been listening to it for less than half a century, which is to say that our understanding of what the ocean sounds like, across its full depth and breadth and frequency range, is still in its early stages. There is comfort in that, if you're looking for it. Not everything needs to be heard. Not every signal needs a receiver. The ocean can make its sounds for its own purposes, if purpose is even the right word for something that is mostly geological. And you can lie in your room and the sounds can be happening and the distance between you and them can be vast and complete. Two worlds of sound, separated by the surface of the water, coexisting without interference. The ocean makes sounds. That much is settled. But it also makes something else, something that seems almost impossible until you see it, and even then requires a moment to accept as real rather than imagined. The ocean makes its own light, not reflected light, not sunlight scattered through the water column, not the glow of a city on the shore bleeding into the waves, its own light, manufactured in the dark, by organisms that learned to glow before anything on earth had learned to see. That is where this goes next, into the light that comes from the dark. Close your eyes if they are not already closed, and think about darkness for a moment. Not metaphorical darkness, real darkness, the kind you get in a room with no windows, no electronics, no clock face glowing on a nightstand, total absence of photons reaching the retina. The body has a specific response to this kind of darkness. The pupils dilate as far as they can, trying to gather light that is not there. The visual cortex, starved of input, sometimes invents its own, generating faint patterns, phosphenes, the quiet fireworks of a brain filling in the blank. In true darkness, the body looks for light the way a hand looks for a surface, reaching, finding nothing, and eventually settling into the nothing as a fact rather than a problem. Now consider the deep ocean. Below about 1,000 meters, roughly 3,300 feet, sunlight does not penetrate. This is the boundary of the photic zone, the layer of ocean where enough light reaches to support photosynthesis. Below it is the aphotic zone, which is a scientific way of saying the dark part, and the dark part accounts for the vast majority of the ocean's volume. The average depth of the world's oceans is roughly 12,000 feet, or about 2.3 miles. The sunlight gives up after the first 1,000 feet. Everything below that, everything in the midnight zone, the abyssal zone, the hadal zone, exists in a darkness that has no equivalent on land. It is not nighttime darkness which is temporary and relieved by stars and the moon and the glow of the sky itself. It is permanent darkness, total, unbroken, unchanging. The same at noon as at midnight, the same in summer as in winter. A darkness that does not know what light is, because light has never arrived there, not once, not in the billions of years that the deep ocean has existed. And yet, if you could descend through this darkness in a submersible with the external light switched off, you would not see nothing. You would see light. Bioluminescence, the production and emission of light by a living organism. It is estimated that roughly 76% of ocean creatures are bioluminescent. Not 76% of deep-sea creatures, though the percentage is even higher there. 76% of all ocean life. 3 out of every 4 marine organisms have the ability to produce their own light. The chemistry is understood, at least in outline. An enzyme called luciferase acts on a light-emitting molecule called luciferin in the presence of oxygen, producing a photon. The reaction is remarkably efficient. Almost no heat is generated. The light is what chemists call cold light, and it comes in a range of colours, though the deep ocean strongly favours blue and green, which are the wavelengths that travel farthest through seawater. Evolution, if you want to think of it this way, has tuned the light to the medium. What is not understood, not fully, is why. Why did so many organisms across so many unrelated lineages evolve the ability to produce light? Bioluminescence has evolved independently at least 50 times across the tree of life. It appears in bacteria, in dinoflagellates, in jellyfish, in fish, in crustaceans, in worms, in squid. The fact that it has evolved so many times, independently, in so many different groups, suggests a powerful selective advantage. But the specific advantage varies by organism, and is not always clear. Some uses are well documented. The anglerfish uses a bioluminescent lure, dangling a glowing appendage in front of its enormous mouth to attract prey in the darkness. Some squid produce bioluminescent ink, a cloud of light rather than a cloud of darkness, to confuse predators. Some organisms use bioluminescence for counter-illumination, producing light on their undersides to match the faint glow from above, eliminating their silhouette and becoming invisible to predators looking up from below. Some use it to communicate, to find mates in the vast darkness, flashing specific patterns at specific frequencies, a language of light in a world without sound's precision. But for many bioluminescent organisms, the function of the light remains genuinely unknown. Why does a deep-sea worm glow? What advantage does a particular pattern of light production provide to a creature living at 4,000 meters in total darkness, in near-freezing water, under hundreds of atmospheres of pressure? The answer is not always obvious, and in many cases it has not been found. In 2024, a team of researchers led by Dr. Danielle DeLeo from Florida International University published a study tracing the evolutionary origin of bioluminescence. They found that the trait first emerged in a group of marine invertebrates called octocorals approximately 540 million years ago, during the Cambrian explosion, the period of rapid diversification that produced most of the major animal body plans that exist today. This makes bioluminescence older than most complex life on Earth. It has been glowing in the ocean for over 500 million years. The first eyes capable of detecting that glow evolved later, which means, and this is worth pausing on, that bioluminescence may have existed in the ocean before there were any organisms that could see it. Dr. John Copley, a deep-sea biologist who has commented on the research, offers an interesting hypothesis. The ocean prior to 540 million years ago was very different from the ocean today. It contained much less oxygen. The rise in oxygen levels that occurred around the time of the Cambrian explosion would have created new chemical conditions in the shallow oceans, conditions that might have incidentally produced light through reactions involving the newly available oxygen and certain biological molecules. Bioluminescence, in this telling, may not have evolved as a signal or a tool. It may have begun as a byproduct of changing ocean chemistry, a chemical accident that only later was co-opted for communication, predation, and defense. The light may have come before the purpose. The glow may have been looking for a reason to exist. I find something genuinely moving about that idea, though I want to be careful not to over-romanticize it. The science is the science. The hypothesis may or may not hold up as more data arrives, but the image of an ocean producing light from itself, involuntarily, as a consequence of chemical change, light that nothing could see because eyes had not yet evolved, that image has a quality that stays with you. A dark ocean, lighting up from within, for no one, not as a signal, not as a tool, just as something that happens when the chemistry is right. The Milky Sea phenomenon is the largest visible expression of bioluminescence that humans have documented. It is the name given to vast patches of ocean, primarily in the Indian Ocean and the waters around the maritime continent, that glow with a uniform milky sheen, sometimes extending over thousands of square miles. The phenomenon has been reported by sailors for centuries. In Jules Verne's 20,000 Leagues Under the Sea, Captain Nemo observes what appears to be a milky sea. The first satellite confirmation came much later, when researchers analysing data from space-based instruments identified the characteristic glow in the waters of the northwest Indian Ocean. The cause is bioluminescent bacteria. Specifically, massive blooms of light-producing bacteria, likely Vibrio harveyi or related species, that colonize the surface of the water in such density that their collective glow becomes visible from space. The bacteria produce light through a mechanism called quorum sensing, in which individual bacteria detect the density of their own population and, when the density exceeds a certain threshold, switch on their bioluminescent genes simultaneously. The light is, in a sense, a coordinated act, a communal decision made by billions of individual organisms that, below a certain density, remain dark, and above it, light up together. The trigger for these massive blooms is not fully understood. Why do the bacteria aggregate in such extraordinary numbers in certain places at certain times? What oceanographic conditions produce a milky sea? The full picture remains incomplete. Imagine it for a moment. An ocean glowing, not from reflected starlight or moonlight, from the water itself. From billions of organisms living in the surface layer, each one a tiny point of biochemical light, and all of them together producing a glow visible from orbit. Sailors who encountered milky seas in the centuries before the bacterial explanation described them as otherworldly, as ghostly, as the ocean becoming something it should not be. And they were right, in a way. The ocean was becoming something other than what it usually appears to be. It was showing its inner light, the darkness that the ocean is famous for, the blackness of the deep, the midnight zone, the abyssal dark. The darkness is real, but it is not the whole story. The ocean also glows. It has been glowing for 540 million years. The light is made from chemistry, not from the sun. It requires no external source. The organisms produce it themselves, using molecules they synthesize from the elements dissolved in seawater, elements that were put there by geological processes that have been running for billions of years. The light in the ocean is the ocean's own light, and the dark is not the absence of that light. The dark is the background against which the light appears, the canvas, the context. Without the depth of the darkness, the bioluminescence would be invisible. It is the darkness that makes the light meaningful, not as a metaphor, as optics, as physics. The signal is only detectable because the noise floor is so low. The glow is only visible because the deep ocean provides a darkness so complete that even the faintest photon stands out. Think about the room you are in. If the room were flooded with bright light, a firefly in the corner would be invisible. But in true darkness, a single firefly would be a beacon. The deep ocean is a room in the true darkness, and it is full of fireflies, billions of them, trillions, each one producing its own light, for its own reasons or for no reason anyone has fully determined. And the cumulative effect is an ocean that glows in the dark. You cannot see it from where you are. You cannot feel it. The bioluminescence of the deep ocean is as inaccessible to your senses as the cosmic microwave background or the neutrinos passing through your body at this moment. But it is happening. Right now. In every ocean on the planet, organisms are producing light in the darkness, and the light is doing whatever it does, attracting prey, repelling predators, finding mates, or simply existing as a consequence of chemistry that has been running since before anything on Earth had eyes. The ocean glows. The ocean speaks in frequencies below human hearing. The ocean presses with forces that would obliterate the human body. And somewhere in all of that, in the glow and the sound and the pressure, things live that we have barely begun to catalogue. Consider what the deep ocean actually looks like when the bioluminescence is happening. Not from above, from inside. If you were descending in a submersible through the midnight zone with all external lights extinguished, you would not see a uniformly glowing ocean. You would see something more like a night sky, scattered points of light in an otherwise total darkness, each one a separate organism producing light for its own reasons. Some of the lights would be steady, a constant blue-green glow from bacterial colonies or from organisms producing a sustained luminescence. Some would be flickering, rapid pulses that might be communication signals between individuals of the same species, flashes exchanged in the dark at intervals that carry information about species identity, sex, or readiness to mate. Some would be sudden and bright, the alarm displays of organisms that produce a burst of light when threatened, either to startle the predator or to attract a larger predator that might eat the thing attacking them, a strategy called the burglar alarm hypothesis. And some of the lights would be moving. The anglerfish carries its bioluminescent lure on a modified dorsal fin spine that extends over its head like a fishing rod. The lure bobs and glows in the darkness, and whatever small organism is attracted to the light swims toward it and enters the enormous upward-facing mouth that is waiting just below. The vampire squid, which lives at depths between 600 and 1200 meters, produces bioluminescent displays from the tips of its arms and from photophores scattered across its body. When threatened, it can invert its arms over its body like an umbrella, revealing a web of bioluminescent tissue that disorients predators. The vampire squid is neither a squid nor a vampire. It is the sole surviving member of its own order, Vampiromorphidae, a living fossil from a lineage that diverged from other cephalopods hundreds of millions of years ago. And it is one of the most beautiful things in the deep ocean, if your definition of beauty can accommodate an animal that looks like a dark red cloak with glowing blue spots, drifting through water that no sunlight has touched since the ocean began. There are fish in the deep sea that produce red bioluminescence, which is unusual because most deep-sea organisms produce blue or green light, and most deep-sea organisms' eyes are tuned to detect blue or green light. A fish called the dragonfish, genus Malacosteus, produces a red bioluminescent beam from an organ beneath its eye. Because other deep-sea organisms cannot see red light, the dragonfish is essentially hunting with an invisible flashlight. It can illuminate its prey without the prey knowing it is being watched. It is a biological night vision device, a predatory advantage so specialized that it borders on unfair, except that fairness is not a concept the deep ocean has any interest in. The cumulative effect of all this bioluminescence across all the species that produce it, at all the depths where it occurs, is an ocean that is, in its dark zones, not truly dark at all. It is full of light, self-generated, self-regulated, produced by living chemistry for purposes that range from predation to defense to communication to reproduction to purposes that nobody has identified yet. The deep ocean is a place of living light in dead darkness, and the contrast between those two conditions, the biological glow and the geological black, is one of the most visually extraordinary phenomena on Earth, and almost nobody has seen it because almost nobody has been there. If you could somehow see all the bioluminescence in the ocean at once, from above through the water, the planet would not look the way you expect. It would look like it had its own stars. Not the reflected light of the sun off the surface. internal light. Light produced by the ocean's own inhabitants, distributed through the water column from the surface to the deepest trenches, flickering and flashing and glowing in patterns that have been running for over 500 million years. The ocean's light show began long before there were eyes to see it. It is still running. It will continue running long after this particular night has ended. Creatures so strange that they challenge the basic categories of animal life. Organisms so poorly understood that their discovery makes headlines not because of what we learned, but because of how much was revealed about what we did not know. That is the direction this is moving, toward the creatures themselves, the ones we have found, and the ones we have only barely glimpsed, and the ones we suspect are there but have never seen. The deep ocean's residents, the things that live in the room we have barely entered. There's a way of thinking about ocean biodiversity that puts the scale of what we do not know into perspective. The Census of Marine Life, a 10-year international research program that ran from 2000 to 2010, involved over 2,700 scientists from more than 80 nations. It was the most ambitious attempt ever made to catalogue the diversity of life in the ocean. By the time the census concluded, the researchers had described over 6,000 species new to science. 6,000 in 10 years. And at the end of it, the lead scientist estimated that the total number of marine species yet to be discovered may exceed those already known by a factor of 3 or 4. The census did not complete the inventory. It revealed how large the inventory was. It measured the gap, and the gap was enormous. The deep sea, specifically, is where the unknowns concentrate. The shallow waters of the continental shelves, the coral reefs, the coastal ecosystems. These have been studied for centuries. They are accessible. Divers can reach them. Research vessels can sample them. The organisms that live there are, for the most part, documented. Not perfectly, not completely, but documented. Below the continental shelf, beyond the reach of recreational diving, below the depth where sunlight provides useful illumination, the documentation drops precipitously. And below, 1,000 meters, in the Bath, Pelagic and Abyssal and Hadal zones, the documentation approaches zero in many regions. The organisms that live at those depths are known primarily from specimens brought to the surface by trawling nets and remotely operated vehicles, and those specimens represent a tiny, biased sample of whatever is actually down there. The bias is worth noting. Trawling nets catch things that are slow or unlucky. Remotely operated vehicles observe things that are near the seafloor and within the range of their lights and cameras. Fast-moving animals in the water column above the seafloor, animals that avoid light, animals that inhabit regions where no ROV has been deployed, all of these remain unsampled. The deep sea census is a census conducted by looking under a very small number of lampposts and counting what was found there, while acknowledging that the vast majority of the city has never been visited. Start with the one that has occupied the human imagination longer than almost any other sea creature, and yet remains, in the most essential ways, unknown. The giant squid, Architeuthis dux, the animal that may have inspired the legend of the Kraken, the sea monster from Norse mythology, that was said to be large enough to drag entire ships beneath the waves. Jules Verne wrote about it. Herman Melville alluded to it. Sailors told stories about tentacles reaching up from the darkness and pulling men from the deck. The giant squid has been a fixture of maritime horror for centuries, and for most of those centuries, science could not confirm that it actually existed. Dead giant squid have been found, of course. Carcasses have washed ashore or been pulled up in fishing nets for hundreds of years. Scientists knew it was real in the sense that they had physical specimens, but a dead specimen tells you very little about a living animal. It tells you anatomy, size, the contents of the stomach. It does not tell you how the animal moves, how it hunts, how it communicates, where it goes, what it does with its time. The giant squid was a known animal that was essentially unknown. It was not photographed alive until 2004. That date is worth repeating, because it tends to surprise people. 2004, smartphones existed. The International Space Station was in orbit. The internet was well into its second decade, and the giant squid, an animal estimated to grow up to 66 feet long, one of the largest invertebrates on Earth, had never been photographed alive. A team of Japanese researchers, led by Tsunemi Kubodera of the National Science Museum in Tokyo, managed to capture images of a living giant squid at a depth of roughly 900 meters in the Pacific Ocean using a baited camera rig. The squid was aggressive, attacking the bait and losing one of its tentacles in the process. The photographs, when published, were treated as a major scientific event. The creature of legend had been caught on camera for the first time in human history. The first underwater video of a living giant squid did not come until 2012, when a team working with the Discovery Channel filmed one at depth in the Pacific. The footage showed a creature that was both alien and strangely graceful, its enormous eyes, the largest in the animal kingdom, reflecting the light of the submersible, its tentacles moving with a deliberateness that suggested intelligence, or at least a highly developed sensory awareness of its environment. The animal observed the submersible. It did not flee immediately. It watched, and then it moved away into the darkness. Scientists have learned almost nothing about the giant squid's behavior in the wild. How deep do they go? How fast can they move? Do they hunt alone or in groups? How do they reproduce? How long do they live? Do they communicate with each other? The answers to virtually all of these questions remain unknown. The few observations that exist, mostly from baited camera rigs, suggest a solitary predator that lives at mesopelagic to bathypelagic depths, somewhere between 200 and 1,000 meters or more. But the data is so sparse that even basic assertions come with significant uncertainty. Then there is the colossal squid, Mesonychoteuthis hamiltoni, which is a different animal entirely. Shorter than the giant squid in total length, but heavier, with a more massive body and hooks on its tentacles in addition to suckers. The colossal squid lives in the Southern Ocean, in the waters around Antarctica, and it is even less known than its giant cousin. Very few intact specimens have ever been recovered. A colossal squid was filmed for the first time in the 2025, and the animal captured on camera was a baby, roughly 1 foot long. Adults can reach 45 feet. We have filmed the baby. The adults remain, for all practical purposes, unseen in their natural habitat. This is the largest invertebrate on Earth by mass, an animal that lives in one of the least accessible regions of the global ocean, and our total knowledge of its living behaviour is essentially zero. The colossal squid is not a rare species in the sense that there are only a few of them. It is likely abundant in the Southern Ocean. It is a major prey item for sperm whales, which hunt it at depth and bear the scars of its hooks on their skin. But abundance does not equal accessibility. The Southern Ocean is remote. The depths where the colossal squid lives are extreme, and the logistics of observing a deep-sea animal in its natural habitat, in freezing water, under enormous pressure in total darkness, are prohibitively difficult. The blue whale is the largest animal to have ever lived on Earth. Not the largest animal currently alive, the largest animal ever, larger than any dinosaur, larger than any marine reptile from the Mesozoic, larger than anything the evolutionary process has produced in roughly 4 billion years of operation, and we still do not fully understand basic facts about them. Blue whales were hunted nearly to extinction during the whaling era. The global population was reduced to perhaps a few hundred individuals at its lowest point. The species has been recovering slowly since the international moratorium on commercial whaling, but the population remains small enough that individual blue whales are difficult to find, difficult to track, and difficult to study. Their habitat is the open ocean, far from coastlines, and they dive to depths that make continuous observation impossible. What we do not know about blue whales includes how long they live. Estimates range from 80 to over 100 years, but the data is limited. we do not fully understand their migration patterns. Some populations appear to migrate thousands of miles between feeding and breeding grounds, but the routes are not well documented, and some individuals seem to deviate from expected patterns in ways that have not been explained. We do not know what their songs mean. Blue whale vocalizations are among the loudest sounds in the ocean, low-frequency calls that can travel hundreds of miles through the SOFAR channel. The calls have been recorded and analysed extensively. The patterns change over time, with certain phrases appearing and disappearing across years in ways that suggest something like cultural transmission. But the actual function of the calls, what information they carry, what purpose they serve, remains a matter of scientific debate rather than settled knowledge. In 2017, off the coast of Sri Lanka, a video was captured of blue whale behaviour that had never been documented before. The footage showed blue whales rolling and racing at the surface, moving in patterns that some researchers interpreted as a mating ritual. Others disagreed. The video sparked controversy among marine biologists, and the behaviour it captured has not been definitively explained. The largest animal that has ever existed, doing something that scientists cannot agree on the meaning of, in water that humans have been sailing for thousands of years. There are other creatures in the deep ocean that occupy a stranger category, not the large and famous, but the small and utterly unknown. In January and February of 2024, a deep-sea expedition off the coast of Chile, organised by the Schmidt Ocean Institute, uncovered more than 100 previously unknown marine species, 100 new species, in a single expedition. This was not a century of accumulated discovery. It was a few weeks of looking in a place that had not been looked at carefully before. The expedition used remotely operated vehicles to explore depths and habitats that had received little scientific attention. The species they found included creatures that had no existing classification, organisms that were so far outside the known taxonomy that researchers could not immediately identify what branch of the tree of life they belonged to. This is not unusual in deep-sea biology. It happens on nearly every major expedition. The deep ocean continues to produce organisms that are new to science, at a rate that suggests the total inventory of deep-sea life is far from complete. In 1932, the American naturalist William Beebe descended to a depth of 1,550 feet off the coast of Bermuda in a submersible called the bathysphere. During his dive, he observed and described two species of fish that had never been seen before and have never been seen since. He called them the five-line constellation of fish and the pallid sailfin. He described their appearance, their behaviour, the way they moved through the water, and then the bathysphere ascended, and the fish went back to wherever they lived, and in the 90-plus years since, no one has ever observed them again. They remain known only from Beebe's descriptions. They are species that were seen once, by one person, in one submersible on one dive, and then returned to the anonymity of the deep. Whether they are real species or misidentifications by a researcher working under difficult conditions in a small porthole with limited light, is a question that has never been resolved. During an Australian deep-sea expedition, scientists found a creature called the faceless fish, an eel-like animal with no visible eyes and a mouth on the underside of its head. The last time this species had been observed was in 1873, 150 years between sightings. The faceless fish had been living in the deep ocean, doing whatever faceless fish do, for a century and a half, without anyone seeing it or knowing it was still there. There is a phenomenon in deep-sea biology called deep-sea gigantism. Organisms that live in the deep ocean tend in many cases to grow much larger than their shallow water relatives, isopods, which in shallow water are typically small, pill-bug-sized crustaceans, can grow to over 16 inches long in the deep sea. Amphipods reach sizes that would be unusual in shallower environments. The Japanese spider crab, which lives at depths of up to 1,000 feet, can span 12 feet from claw tip to claw tip. The leading hypotheses for deep-sea gigantism include the cold temperatures of the deep, which slow metabolism and may allow longer growth periods, the scarcity of food, which may select for larger body sizes that are more energy efficient, the higher pressure, which may affect growth in ways that are not fully understood, and the absence of predation pressure in some deep-sea environments, which may allow organisms to grow larger than they could in habitats where being big makes you a target. None of these hypotheses is fully satisfying on its own. Deep-sea gigantism may be the result of multiple factors interacting in ways that have not been disentangled. Like many things in deep-sea biology, the phenomenon is observed more reliably than it is explained. The mind builds a model of the world based on what it has seen. You have seen animals on land. You have seen animals in shallow water, if you have been to an aquarium or a tide pool or a coral reef on vacation. These animals form your mental template for what living things look like, how they move, what sizes they come in. The deep ocean does not conform to this template. There is a jellyfish called Turritopsis dornii, sometimes referred to as the immortal jellyfish, that can, when injured or stressed, revert its cells to their earliest form and begin its life cycle again from the beginning, not reproduce, not create offspring, literally transform its adult body back into a juvenile polyp and start over. It is the only known animal that can do this. The mechanism is called transdifferentiation, the transformation of one cell type into another, and while the jellyfish is not truly immortal in any practical sense, because it can still be eaten by predators or killed by disease, the theoretical implication is that it could, under ideal conditions, cycle between its adult and juvenile forms indefinitely. The jellyfish has no brain. It has no centralized nervous system. It has existed for millions of years, and it has solved, or at least sidestepped, the problem of aging in a way that every biomedical researcher on Earth would give a great deal to understand. The nautilus, a cephalopod related to squid and octopus, has been essentially unchanged in its basic form for over 480 million years. The species Nautilus belewensis has ancestors in the fossil record that predate the dinosaurs by roughly 250 million years. When you look at a nautilus, you are looking at a body plan that has persisted through 5 mass extinction events, including the one that killed the dinosaurs, the one that killed most of the trilobites, and the Great Dying at the end of the Permian that eliminated roughly 90% of all marine species. The nautilus survived them all, not by being exceptional, as far as anyone can tell, but by being sufficient, by being good enough at what it does, in the environment where it lives, that 480 million years of catastrophic change could not improve on the design enough to matter. The deep ocean produces organisms that violate the categories. Translucent fish with no scales, worms that live at crushing pressures, bacteria that glow, squid larger than school buses, jellyfish that may be biologically immortal, nautiluses that predate the first land plants, creatures that were last seen in 1873, creatures that have never been seen at all, but whose existence is inferred from traces in the sediment, from chemical signatures in the water, from the scars they leave on the bodies of animals we do know about. There is a category of creature in the deep ocean that scientists refer to informally as megafauna, large animals that live at depth beyond what most research methods can easily reach. The evidence for their existence comes from a variety of indirect sources. The scars on the bodies of sperm whales, which regularly bear circular sucker marks from giant squid encounters at depth, the unidentified bite marks found on the carcasses of large deep-sea fish, marks that do not match any known predator, the occasional sonar readings that suggest large, moving biological targets at extreme depths, readings that are recorded and then never replicated because the animal, whatever it was, moved on. The ocean is large enough and deep enough and dark enough that a population of large animals could exist at depth without ever being observed, simply because the intersection between their habitat and human observation is vanishingly small. We have barely looked. The fact that we have not found something does not mean it is not there. It means we have not spent enough time in its living room. Consider the numbers. The deep sea, defined as everything below 200 meters, comprises roughly 95% of the livable space on Earth. Not 95% of the ocean, 95% of all livable space, period, including the land. The deep sea is the largest habitat on the planet by volume, and the fraction of it that has been directly observed by human eyes or human instruments is so small that it rounds to zero in most estimations. We have sent more people to the moon than to the bottom of the Mariana Trench. We have more detailed maps of the surface of Mars than of our own ocean floor. The presumption that we know what lies in the deep ocean is not supported by the amount of looking we have actually done. The presumption that we have catalogued life on Earth is a land dweller's presumption. On land, where the terrain is accessible and the organisms are visible, the inventory is relatively complete. There are new species found in rainforests and caves, yes, but the major groups are known. In the deep ocean, the major groups may not all be known yet. The basic categories of life may still be incomplete. The tree of life may have branches that have not been drawn because nobody has gone deep enough, often enough, with the right instruments to find them. What lives in the other 73% of the ocean floor that has not been mapped? Nobody knows. That is not a dramatic overstatement. It is the literal answer. Nobody knows what lives in the unmapped regions of the ocean, because those regions have not been surveyed. The organisms there are doing whatever they do, in whatever forms they take, at whatever depth they inhabit, and the sum total of human knowledge about them is zero. Not low, not incomplete. Zero. You cannot have knowledge about a place you have never looked at. This is not a depressing thought. Not necessarily. There is a version of it that feels like loss, like there is some vast library of biological information that we are failing to access. But there is another version that feels more like possibility. The deep ocean is the last great reservoir of undiscovered life on Earth. Every expedition comes back with new species. Every dive produces something unexpected. The rate of discovery has not slowed. If anything, as the technology improves and the reach of remotely operated vehicles extends, the rate is accelerating. The deep ocean is still giving up secrets faster than we can catalogue them. That thought can sit where it is. The creatures are there, in the dark, in the pressure, in the cold. They were there before anyone knew about them. They will be there after everyone alive tonight has become part of the geological record. The deep ocean does not depend on human awareness. It does not need to be known to be real. It just is. And the gap between what is and what is known is, at this point, still very wide. There is something else happening in the ocean right now that does not fit the usual patterns. Something that the usual categories of predator and prey do not quite capture. Off the coast of South Africa, 2 individual animals have changed the ecology of an entire coastline, and the full implications of what they are doing are still being worked out by scientists who are, frankly, astonished. That is the next thing. Off the southwestern coast of South Africa, in the waters around Cape Town and Gansbaai and Mossel Bay, great white sharks used to be common. Not just present, common. Gansbaai, a small town about 100 miles east of Cape Town, was known globally as the great white shark capital of the world. Cage diving operations took tourists out daily to see the sharks up close, and the sharks were reliably there, hunting seals around Dyer Island, patrolling the coastal waters in numbers that made sightings routine. The great whites were a defining feature of the ecosystem. They had been there, in those waters, doing what apex predators do for as long as anyone could remember. Then they started disappearing. Not gradually, not in the slow decline that overfishing produces, not in the generational thinning that habitat loss causes. They disappeared in events. A few sharks would wash ashore, dead, and when researchers examined the carcasses, they found something disturbing. The sharks' livers had been removed, not crudely, not torn out in the chaos of a fight. Removed with what researchers described as near-surgical precision, through a clean tear in the pectoral region. The rest of the organs were intact. The rest of the body was largely undamaged. Whoever or whatever had killed these sharks was interested in one thing, the liver, and it had the skill to take it and leave the rest. The first documented case of this pattern appeared in 2015 when 7 gill shark carcasses with pectoral tears and missing livers began washing ashore near Cape Town. A marine biologist named Alison Koch, working with South African national parks, conducted necropsies on the carcasses and found something she had not expected: orca tooth impressions in the tissue around the tears. The clean wounds had been made by killer whales, not a pod of killer whales, not a large hunting group operating in the coordinated way that orcas are known for. 2 individual male orcas, a pair. They were identified by a distinctive feature that made them easy to recognize from a distance. Their dorsal fins were bent, collapsed to one side in a way that is relatively unusual in wild orcas. One fin bent to the left, the other to the right. Researchers named them port and starboard, after the navigational terms for the left and right sides of a vessel. Port and starboard had not been known to hunt sharks before. Orcas worldwide eat a wide variety of prey, and different populations specialize in different food sources. Some eat primarily salmon, some eat seals, some eat other whales. But the systematic, surgical removal of shark livers was something new. Researchers called it a novel and specialized technique. The precision of the extraction was remarkable. The orcas were not simply killing sharks and eating what they could. They were targeting a specific organ, the liver, which in great white sharks is an enormous structure, roughly a third of the animal's total body mass, rich in a lipid called squalene. A single great white liver, according to marine biologist Ralph Watson of the Dyer Island Conservation Trust, might contain enough calories to sustain an orca for a day. In 2017, 5 great white sharks washed ashore near Gansby, all with livers removed in the same characteristic manner. Port and starboard were suspected, but it was not until May 2022 that aerial drone footage first captured the orcas in the act of killing a great white shark. The footage confirmed what the carcasses had suggested. The orcas were targeting great whites specifically, using a technique that involved gripping the shark by the pectoral fin and manoeuvring it until the liver could be accessed. Then, in February 2023, the pair killed 19 broad-nosed 7-gill sharks in a single day at Pearly Beach, near the southernmost tip of South Africa. 19, in one day, all with livers removed, all with the same clean pectoral tears. The carcasses washed ashore and were documented by researchers from Marine Dynamics, a local conservation organisation, and then came the event that changed how scientists understood port and starboard's capabilities entirely. On June 18th, 2023, near Seal Island in Mossel Bay, about 400 kilometres east of Cape Town, researchers and tourists on 2 observation vessels watched starboard hunt and kill a great white shark, alone, without port's assistance. Port was observed roughly 100 metres away and did not participate in the kill. Starboard gripped the shark, a juvenile great white measuring approximately 2.5 metres, by its left pectoral fin, thrust forward with the shark several times and eviscerated it in under 2 minutes, less than 2 minutes from the first contact to the extraction of the liver. The researchers who witnessed it described it as astonishing. Later, starboard was photographed from one of the vessels, carrying a bloody piece of peach-coloured liver in its mouth. A second great white carcass, measuring 3.5 metres, washed ashore the following day in the vicinity, indicating that at least 2 sharks had been killed during the encounter. The findings were published in the African Journal of Marine Science in 2024 by a team led by Alison Towner, a shark biologist at Rhodes University. The solo kill was significant because it changed the understanding of what these orcas were capable of. Orcas are known to hunt cooperatively, using coordinated strategies to take down large prey. The fact that starboard could single-handedly kill a great white shark, one of the most formidable predators in the ocean, in under 2 minutes, suggested a level of individual skill that went beyond what cooperative hunting would require. It raised the question of whether these orcas had developed and refined this technique over years of practice, accumulating expertise the way a craftsman accumulates skill. The ecological consequences have been dramatic and are still unfolding. After the June 2023 kill in Mossel Bay, great white sharks left the area for approximately 4 months. This pattern has been observed repeatedly along the South African coast. When port and starboard appear in an area, the great whites leave, not just the individual sharks that witnessed the kill, the entire local population. Somehow the sharks know. Whether through chemical cues, changes in the behaviour of other marine animals, or some other mechanism, the great whites detect the presence of the orcas and vacate the area. Gansbai, once the great white capital of the world, has seen a dramatic decline in great white shark sightings in recent years. The cage diving industry has been affected. The ecosystem has begun to shift. Without apex predators patrolling the coastal waters, prey species like Cape fur seals and certain fish populations may increase, which in turn affects the species those animals eat, and so on down the food chain. 2 individual orcas have triggered a trophic cascade, a chain reaction through the food web along an entire stretch of coastline. The questions that remain open are significant. Where did port and starboard come from? Orcas are not historically common in the waters around the Cape. Were they always there, unnoticed, or did they arrive from elsewhere? If they arrived, what drove them to this particular region, and why did they develop this particular hunting technique? Little is known about the animals beyond their hunting behaviour. Their ages are unknown. Their genetic relationship to each other is unknown, though researchers suspect they may be brothers. Their broader travel patterns have been tracked to some extent, with sightings reported along South Africa's eastern coastline and as far north as Namibia, but their full range is not established. Is the behaviour spreading? This is the question that concerns researchers most. Orcas are intelligent animals with complex social structures and the capacity for cultural transmission, the ability to learn behaviours from one another and pass them across generations. If port and starboard are teaching other orcas to hunt sharks for their livers, the ecological impact could extend well beyond the South African coast. There is some evidence that other orcas have been observed in the region, and the possibility that the behaviour is being adopted by additional individuals cannot be ruled out. The question of cultural transmission in orcas is worth pausing on because it is one of the more remarkable features of these animals, and it is directly relevant to what is happening off South Africa. Orcas live in family groups called pods, and within these pods, behaviours are transmitted from older to younger members through observation and imitation. Different orca populations around the world exhibit entirely different hunting strategies, diets and social behaviours, not because of genetic differences, but because of learned traditions passed down through generations. In the North Pacific, resident orcas specialise in salmon, and have developed techniques for catching specific species at specific locations that are unique to their pod. Transient orcas in the same waters specialise in marine mammals and use completely different hunting strategies. The 2 populations overlap geographically, but behave as though they inhabit different worlds. This capacity for cultural learning means that a new behaviour, once developed by an individual or a pair of individuals, can potentially spread through a population. It is not just instinct, it is innovation. Port and starboard appear to have developed a specific refined technique for extracting shark livers, and the question of whether this technique can be transmitted to other orcas is not hypothetical. Orcas have been documented learning new hunting behaviours from observation in other parts of the world. The wave washing technique used by Antarctic orcas to knock seals off ice floes appears to be a culturally transmitted behaviour. The practice of beaching themselves to catch seals on the shore, used by a population of orcas in Argentina, is taught by mothers to their calves through deliberate training sessions. These animals learn, they teach, they innovate, and they remember. What port and starboard have done is not without precedent in the broader context of orca behaviour worldwide. In the Gulf of California, Orcas have been observed paralysing young great white sharks before extracting their livers, using a technique similar to what has been documented in South Africa. Off the coast of Europe, particularly around the Strait of Gibraltar and the coast of Portugal, orcas have been engaging in another baffling behaviour that has drawn global attention. They have been ramming and damaging sailboats. Dozens of incidents have been recorded since 2020, with orcas approaching small vessels, striking their rudders repeatedly, and in some cases causing enough damage to sink the boats. The behaviour appears to be concentrated in a subpopulation of Iberian orcas, and its cause is debated. Some researchers believe it may have started with a traumatic event experienced by a single individual, a female orca named White Gladys, who may have been injured by a boat and subsequently began interacting aggressively with similar vessels. Others believe the behaviour may be a form of play that has escalated, or a culturally transmitted novelty that spread through the population, because orcas, particularly young ones, are curious and imitative. Whatever the cause, the pattern is consistent. Orcas around the world are exhibiting new behaviours that were not observed a decade ago, behaviours that spread through populations via cultural transmission, behaviours that have consequences for other species and for human activities. The ocean's most intelligent predators are adapting, innovating and changing their strategies in real time, and the pace of that change is faster than the scientific community's ability to explain it. There is something about this that feels different from the other mysteries in this night's thinking. The unmapped ocean floor is a mystery of ignorance, of not having looked. The sounds in the deep are a mystery of interpretation, of signals received without full understanding. The creatures in the abyss are a mystery of access, of habitats too extreme to visit easily, but the orcas are a mystery of intelligence, of animals making decisions, developing skills, transmitting knowledge, and altering ecosystems through deliberate, learned behaviour. The mystery is not what is happening. We can see what is happening. The mystery is why. Why did these two orcas, out of all the orcas in the world, develop this specific technique? Why did they target great white sharks, the apex predator of the coast they inhabit? What cognitive process led them to identify the liver as the most valuable organ and to develop a method for extracting it with such efficiency? These are questions about the inner life of an animal whose intelligence we have only begun to measure, whose cognitive world we can observe from the outside but cannot enter, whose reasons, if reasons is the right word, are as opaque to us as the deep ocean itself. Alison Towner, the lead researcher documenting the phenomenon, has noted that while human activities like overfishing and climate change pose far greater threats to shark populations than two individual orcas, the added predation pressure on an already stressed population is concerning. Great white sharks reproduce slowly. They take years to reach maturity. They produce relatively few offspring. A population that is already reduced by human impacts may not be able to absorb the additional mortality that consistent orca predation imposes. There is also the broader question of what port and starboard's behaviour tells us about the ocean's stability, or rather, about the illusion of stability that we project onto ecosystems. We tend to think of the ocean's food web as a fixed structure. Predators eat prey, prey sustains predators, the relationships are stable, the balance is maintained, and the ecosystem persists in a state of equilibrium. But what port and starboard have demonstrated is that the food web is not a structure. It is a set of relationships, and those relationships can change with startling speed. Two individual animals, two orcas with bent dorsal fins and an appetite for shark liver, have redrawn the ecological map of a coastline. The equilibrium was not equilibrium. It was a pattern that happened to hold until something changed. The ocean does this. It holds patterns for long enough that the patterns start to feel permanent, and then something shifts, and the pattern dissolves and a new one forms, and the new one also feels permanent until the next shift. The ocean is not stable, it is patient. There is a difference. Stability implies a fixed state. Patience implies a state that holds because nothing has yet disrupted it. The disruption, when it comes, reveals that the holding was always temporary. The orcas disrupted the holding. The great whites left. The seals may increase. The fish the seals eat may decrease. The organisms those fish depend on may change. The whole web adjusts, and the new pattern holds until the next disruption, which may come from another predator, or from a change in water temperature, or from a shift in ocean currents, or from a factor that nobody has thought to measure. The ocean's ecology is not a machine with fixed parts. It is something more like a conversation between organisms, each one responding to what the others are doing, and the conversation can change direction at any time without warning, in response to inputs that the participants themselves may not be aware of. Tonight, somewhere off the coast of South Africa, port and starboard are either hunting or travelling or resting, doing whatever orcas do in the dark. The great whites, wherever they have relocated, are patrolling their new waters, which are not really their waters at all, because no ocean territory belongs to anyone. The seals at Dyer Island are either safer or less safe than they were a decade ago, depending on which predator you ask. The trophic cascade is unfolding in real time, and it will continue to unfold whether or not anyone is watching. The orcas changed the coast, but the ocean has changed coastlines before, in ways that are harder to explain and harder to accept. Ships vanish, islands disappear. Entire stretches of water acquire reputations that science has never fully accounted for. The ocean has a long history of taking things and not giving them back, and that history, the vanishings, the absences, the things that went into the water and were never seen again, is waiting in the next thought. On the 4th of December, 1872, a small British brigantine called the Dei Gratia was sailing west across the Atlantic, roughly 400 miles east of the Azores, when her crew spotted another vessel drifting erratically on the horizon. The ship was the Mary Celeste, an American merchant brigantine that had left New York 8 days before the Dei Gratia, bound for Genoa, Italy, carrying a cargo of industrial alcohol. When the crew of the Dei Gratia boarded the Mary Celeste, they found her in generally seaworthy condition. The cargo was largely intact. The personal belongings of the crew were still aboard. Food and water supplies remained. The ship was not sinking. She was not on fire. There were no signs of violence, no blood, no bodies, no evidence of piracy or struggle. The entire crew was gone. 10 people. Captain Benjamin Briggs, his wife Sarah, their 2-year-old daughter Sophia, and 7 crew members. All gone. The ship's only lifeboat was missing, suggesting that the crew had abandoned the vessel deliberately, but there was no obvious reason for them to have done so. The weather at the time, while rough, was not catastrophic. The ship was not in danger, or at least not in any danger that was evident from the condition in which she was found. The crew had simply left in the middle of the Atlantic, in a lifeboat, for reasons that have never been determined with certainty. In the more than 150 years since the Mary Celeste was found adrift, dozens of theories have been proposed. Mutiny, piracy, alcohol fumes from the cargo causing an explosion scare, a waterspout, an underwater earthquake producing a seaquake that shook the vessel and frightened the crew into believing she was sinking. More recently, modern investigators have suggested that faulty navigational instruments may have led Captain Briggs to believe the ship was closer to land than it actually was, and that the cargo was leaking or unstable, creating a combination of circumstances that made abandoning ship seem like the rational choice. No theory has been confirmed. The 10 people aboard the Mary Celeste were never found. The lifeboat was never found. Whatever happened in the hours or days before the Dei Gratia spotted the drifting ship, whatever decision was made and by whom and for what reason, the information went into the Atlantic with the missing crew, and the ocean did not give it back. The Mary Celeste is perhaps the most famous maritime vanishing, but it is not the largest, and it is not the most inexplicable. That distinction may belong to the USS Cyclops. In March 1918, the USS Cyclops, one of the United States Navy's largest fuel ships, departed Barbados with 309 people aboard, bound for Baltimore, Maryland. She never arrived. No distress signal was sent. No wreckage was ever found. No bodies were recovered. The ship simply disappeared somewhere in the western Atlantic, taking every soul aboard with her. It remains the largest non-combat loss of life in the history of the United States Navy. Over 100 years of searching, including with modern sonar and satellite technology, has produced nothing. The Cyclops is gone. The ocean took her completely. The area where the Cyclops vanished overlaps with the region commonly known as the Bermuda Triangle, the roughly 500,000 square miles of Atlantic Ocean, between Bermuda, Miami and San Juan, Puerto Rico, that has acquired a reputation for unexplained disappearances of ships and aircraft. The reputation is more complicated than popular culture suggests. Statistical analyses have shown that the Bermuda Triangle does not actually have a higher rate of disappearances than other comparable regions of the ocean. Ships and aircraft go missing everywhere, and the Atlantic is a busy, dangerous body of water where storms, equipment failures, and human error produce regular casualties. The Bermuda Triangle's reputation may be more a product of selective attention and narrative momentum than of any genuine anomaly in the region, but that statistical context does not change the specific individual disappearances that remain unexplained. Flight 19, a group of 5 Navy torpedo bombers that vanished during a training exercise in December 1945. The aircraft were never found. The rescue plane sent to search for them also vanished. The Cyclops, the SS Marine Sulphur Queen, a tanker that disappeared in February 1963 with 39 crew members. Individual cases that, however statistically normal they may be in aggregate, represent real people who went into the ocean and did not come back, in circumstances that have never been fully reconstructed. On the other side of the world, in the Western Pacific, there is a region called the Devil's Sea, sometimes known as the Dragon's Triangle, that has a similar reputation. Located roughly between Japan, the Bonin Islands and Guam, the Devil's Sea is described in some accounts as the Pacific equivalent of the Bermuda Triangle, a zone of mysterious disappearances and unexplained phenomena. The Japanese government declared the area too dangerous for voyages after a research vessel, the Kaiomaru No. 5, was sent to the region in 1952 to investigate previous ship disappearances, and itself went missing with all hands aboard. That detail is worth sitting with. A ship sent to investigate why ships were disappearing in an area disappeared itself. The investigation became the mystery. The most likely explanation for the Devil's Sea's dangers is mundane, but no less lethal for being understood. The region is seismically active, with underwater volcanoes and tectonic instability that can produce sudden, unpredictable changes in ocean conditions. Methane gas eruptions from the seabed can, in theory, reduce the density of the water enough to cause a ship to lose buoyancy and sink rapidly. Rogue waves, which are abnormally large and steep ocean waves that emerge without warning, have been documented in the region. None of these explanations is supernatural. All of them are deadly. The Devil's Sea is dangerous not because something mysterious is happening there, but because the ocean in that region is doing what the ocean does, being the ocean, with particular geological intensity. In July 1909, the SS Waratah, a passenger steamship, departed Durban, South Africa, bound for Cape Town. She was carrying over 200 passengers and crew. She was never seen again. Not the ship, not the passengers, not a single piece of identifiable wreckage. Over a century of searches, using everything from simple visual observation to sophisticated sonar mapping, has failed to locate the Waratah. The ship vanished off the eastern coast of South Africa, in waters that are known for severe storms and unpredictable currents, and the ocean absorbed her so completely that it is as if she never existed. The Waratah is not unique in this. The ocean's ability to consume evidence is, when you think about it, one of its defining characteristics. On land, when something is lost, it is usually findable. A building collapses and leaves rubble. A vehicle crashes and leaves wreckage. A person dies in the wilderness and eventually bones are found. The physical evidence of the event persists in the environment because the environment on land is, for the most part, a preserving medium. Things settle. Things remain. The ocean is not a preserving medium. It is a dissolving medium, a dispersing medium, a medium in constant motion. Currents carry debris across thousands of miles. Salt water corrodes metal. Marine organisms colonize and consume organic material. The pressure at depth can crush structures that would survive any conditions on land. A ship that sinks in deep water descends into an environment that is actively hostile to the preservation of evidence. The wreckage may be scattered by currents. It may be buried by sediment. It may be consumed by biological processes. It may end up so deep that the technology required to locate it does not exist or is prohibitively expensive to deploy. The surface of the ocean tells you nothing about what is underneath. You can sail over the exact spot where a ship went down and see only water, flat and featureless and indifferent. The ocean's surface is not a record, it is a curtain. What happens beneath it stays beneath it unless someone goes looking with the right instruments, in the right place, at the right depth, with enough funding and enough time. In 1968, the world experienced what might be the most concentrated period of submarine disappearances in modern history. 4 submarines from 4 different nations were lost within the span of a few months. The Israeli submarine Dhaka vanished in the Mediterranean in January. The French submarine Minerve disappeared in the same month. The Soviet submarine K-129 was lost in the Pacific in March. And in May, the American submarine USS Scorpion disappeared in the Atlantic while returning to base from the Mediterranean. All 4 submarines have since been located. The Dakar was found in 1999 at a depth of roughly 3,000 meters in the Mediterranean. The Minerve was found in 2019, 51 years after it vanished, at a depth of 2,300 meters off the coast of Toulon, France. The K-129 was found by the CIA in the 1970s, and a secret operation called Project Azorian was launched to recover the wreckage from the Pacific floor without the Soviet Union knowing about it. The Scorpion was located in October 1968, its hull shattered on the Atlantic seabed. Finding the submarines answered the question of where they were. It did not answer the question of why they sank. In none of the 4 cases has a definitive cause been established. Equipment failure, accidental torpedo detonation, structural failure under pressure, human error. These are all possibilities. The Soviet submarine K-129 has been the subject of particularly intense speculation, with some theorists suggesting it was attacked, though no evidence supports this conclusively. The near-simultaneous loss of 4 military submarines from 4 nations remains one of the most perplexing coincidences in naval history. It is deeply unlikely that the events are connected, but the clustering of losses in such a short period remains unexplained, and if nothing else, serves as a reminder that even the most advanced vessels ever built by human civilization are not immune to the ocean's capacity for destruction. There is a specific disappearance that has become almost synonymous with the Bermuda Triangle, and it is worth telling here not because it confirms anything supernatural about that region of the Atlantic, but because the specific details of what happened resist the clean explanations that usually follow. On December 5, 1945, 5 Navy TBM Avenger torpedo bombers, designated Flight 19, departed from Fort Lauderdale, Florida, on a routine training exercise. The flight was led by Lieutenant Charles Taylor, an experienced pilot. The exercise was supposed to last about 2 hours. The planes flew east over the Atlantic, completed their practice bombing runs, and then turned north. At some point during the return leg, something went wrong with the navigation. Radio transmissions from Flight 19, intercepted by ground stations and other aircraft, indicate that Lieutenant Taylor became disoriented. His compass appeared to be malfunctioning, or he believed it was. He reported that both of his compasses were out. He could not identify the landmarks below. He believed the flight had drifted off course, but he was unsure in which direction. Over the next several hours, the transmissions became increasingly confused. Taylor's radio contact with the base deteriorated as the flight moved further away, and the last transmissions were broken and barely intelligible. The 5 planes, carrying 14 men, were never seen again. No wreckage was ever recovered. No bodies were ever found. A Martin PBM Mariner flying boat, with 13 crew members aboard, was dispatched to search for Flight 19. It also vanished. A ship in the area reported seeing an explosion in the sky around the time the Mariner disappeared. The PBM Mariners were known to leak fuel vapours and had earned the informal nickname Flying Gas Tanks. The most likely explanation for the search plane's disappearance is an in-flight explosion caused by fuel vapours igniting. But the wreckage of the Mariner, like the wreckage of Flight 19, has never been found. 6 aircraft, 27 men, gone, in an afternoon, in waters that thousands of vessels cross safely every year. The ocean floor beneath the Bermuda Triangle region is not unusual in any geological sense. It includes the continental shelf off the Florida coast, the deep waters of the North Atlantic, and the Puerto Rico Trench, which at roughly 28,000 feet is the deepest point in the Atlantic. Storms are common. The Gulf Stream, one of the most powerful ocean currents in the world, flows through the region, capable of scattering debris across vast distances in a matter of hours. Aircraft that crash into the deep Atlantic can sink to depths where recovery is, with existing technology, either impossible or prohibitively expensive. The conditions for making things disappear without a trace are, in the Bermuda Triangle, entirely natural and entirely sufficient. And yet, the fact that the wrecks of Flight 19 have never been found, despite decades of searching with increasingly sophisticated sonar and underwater survey equipment, is genuinely strange. Not supernatural, but strange. The Atlantic took those planes and absorbed them so thoroughly that 70 years of looking has not produced a single confirmed piece of wreckage. It is estimated that there are over 4,000 shipwrecks scattered across the floor of the Gulf of Mexico alone. 4,000. Each one a vessel that went down at a specific time, for specific reasons, carrying specific people who had specific lives, and the vast majority of them have never been found or identified. In 2019, sonar technology detected an unknown shipwreck in the Gulf, and a live video feed from the seafloor revealed a 19th century vessel, approximately 124 feet long, built of wood with copper sheathing. The ship's country of origin is unknown. The number of crew aboard is unknown. Its purpose is unknown. How it sank is unknown. It sits on the Gulf floor, anonymous, one wreck among 4,000, holding its story in a silence that the ocean has no interest in breaking. There is a rare weather phenomenon that occurs at sea called a fata morgana, or cold water mirage. It happens when a layer of cold air sits beneath a layer of warmer air, creating a thermal inversion that bends light in unusual ways. The result is a natural, optical illusion in which objects on the horizon appear distorted, elevated, or duplicated. Ships can appear to float above the water. Land masses can seem to hover in the sky. In extreme cases, objects below the optical horizon, things that should be invisible due to the curvature of the Earth, can appear as ghostly images above the waterline, visible to observers who, by all the normal rules of optics, should not be able to see them. Some researchers have suggested that Fata Morgana may have contributed to the Titanic disaster in 1912. The ship sailed into the cold Labrador Current, which collided with the warmer Gulf Stream waters, creating conditions ideal for thermal inversions. If the lookouts were experiencing a Fata Morgana, the iceberg that struck the Titanic may have been optically distorted or hidden within a false horizon. The theory is speculative, but the phenomenon itself is real, and its effects on navigation in the era before radar and GPS were potentially significant. Sailors throughout history have reported seeing islands and ships that were not there, or that were there but not where they appeared to be. The ocean's atmosphere plays tricks on the eyes, and those tricks, in an era when navigation depended on visual observation, could be fatal. The ocean is not just a body of water. It is an optical environment, an acoustic environment, a thermal environment, a pressure environment, and a chemical environment, and each of these layers of physical reality behaves differently from the corresponding layer on land. Light bends differently over water. Sound travels differently through water. Temperature gradients create effects that have no equivalent on land. The ocean is a different kind of space than land, not just wetter, but fundamentally operating under different physical rules, and the things that happen in that space, the disappearances, the misjudgments, the losses, often reflect the specific ways in which the ocean's physics differs from the physics the human body evolved to navigate on dry land. We are land animals. Our senses are calibrated for land. When we venture onto the ocean, we bring our land-calibrated senses into an environment where they are, in several important respects, wrong. And sometimes that wrongness costs lives. And then there is the matter of islands that simply cease to exist. Sandy Island was charted by Captain James Cook in 1774 during his second voyage to the Pacific. It appeared on his chart of discoveries made in the South Pacific Ocean. The island was reported again in 1876 by the crew of the whaling ship Velocity. It subsequently appeared on numerous maps and nautical charts. It appeared on Google Maps. It was, as far as the cartographic record was concerned, a real place, a small island in the Coral Sea between Australia and New Caledonia. In 2012, a team of Australian scientists aboard the research vessel Southern Surveyor sailed to the coordinates where Sandy Island was supposed to be. They found open ocean, no island, no shallow water, no reef. The depth at the supposed location of Sandy Island was over 4,300 feet. There was nothing there. The island had either never existed, in which case it had persisted on maps for nearly 240 years as a cartographic error, or it had once existed and had since been destroyed by volcanic activity or subsidence. Either way, it was gone. The maps were wrong, the ocean was right. In the Solomon Islands, the island of Tionyamanu vanished centuries ago, swallowed by the ocean after what was likely a catastrophic underwater landslide triggered by volcanic activity. Oral histories of the Solomon Islanders describe the disappearance. The island was there, and then it was not. The ocean closed over it, and the place where people had lived and fished and built their homes became open water. The Sargasso Sea sits in the North Atlantic, bounded not by land but by ocean currents. The Gulf Stream to the west, the North Atlantic Current to the north, the Canary Current to the east, and the North Atlantic Equatorial Current to the south. It is the only sea on Earth that has no coastline. Its boundaries are defined entirely by the rotation of water. Within it float vast mats of sargassum seaweed, golden brown and tangled, forming floating ecosystems that support their own communities of organisms. The Sargasso Sea has historically been a source of unease for sailors. Becalmed ships could become tangled in the weed. The water is unusually clear and deep, and the stillness of it, the lack of current within the slow rotating gyre, has given it a reputation for trapping and holding whatever wanders in. The reputation is largely undeserved. The Sargasso Sea is not a trap. It is an ecosystem, and a poorly understood one at that. The reproductive cycle of the European eel, one of the great unsolved mysteries of marine biology, is believed to involve the Sargasso Sea, where adult eels are thought to spawn after crossing the entire Atlantic from European rivers. But no one has ever observed European eels spawning in the Sargasso Sea. The evidence is circumstantial, based on the presence of the smallest known eel larvae in the region. The actual spawning has never been seen. The eels arrive, presumably, and do what they came to do, and the ocean keeps the details to itself. The vanishings are not a category of mystery, so much as a quality of the ocean itself. The ocean takes things. It takes ships. It takes people. It takes islands, it takes evidence, and it does not always give them back. Not because it's malicious, not because it is hiding something, but because the ocean is a vast, deep, dynamic, corrosive, light-blocking, pressure-imposing, current-driven environment in which the conditions for preserving information are the exception rather than the rule. On land we are used to the world keeping records, footprints in mud, fossils in rock, ruins in the desert. The physical world on land preserves the evidence of what happened in it, imperfectly but consistently, enough that we can read the past from the present. The ocean does not do this in the same way. The ocean's records are different, written in sediment chemistry, in the shells of microscopic organisms, in the isotope ratios of coral growth rings. These records exist, and they are rich, but they do not preserve the specific narrative details that the human mind craves. They do not tell you where the Mary Celeste's crew went. They do not tell you why the Cyclops sank. They do not tell you what happened to Sandy Island. The ocean keeps its own records, and they are not the records we would choose. But the ocean also builds. Beneath the surface there are structures that challenge what we think we know about who built what and when. Formations that look like they were made by hands, sitting at depths that make hands unlikely. Objects that defy easy classification, sitting on the ocean floor, waiting for an explanation that has not yet arrived. That thought is close. That is the next thing. Off the southern coast of Yonaguni Island, the westernmost inhabited island of Japan, there is something on the ocean floor that has been generating argument among scientists for over 3 decades. It sits in shallow water, relatively speaking, at depth between about 5 and 40 meters. It was discovered in 1987 by a diver named Kihachiro Aratake, who was exploring the area in search of hammerhead sharks and found instead a series of massive stone formations that looked unlike anything natural he had ever seen. The Yonaguni Monument, as it came to be known, consists of large flat rock surfaces arranged in what appear to be terraces, steps and right angles. There are features that resemble staircases. There are flat platforms with sharp edges. There are what look like carved channels and symmetrical faces. If you saw photographs of the formation without knowing its context, you might reasonably guess that it was the remains of a man-made structure, a temple, perhaps, or a stepped pyramid, or some kind of ceremonial platform built by an ancient civilization and subsequently submerged by rising sea levels. That is precisely what some researchers have argued. Masaki Kimura, a marine geologist at the University of the Ryukyus in Okinawa, studied the monument for years and concluded that at least some of the features show evidence of human modification. He pointed to the regularity of the steps, the right angles, the symmetry of certain formations, and the presence of features that he argued could not have been produced by natural geological processes alone. Kimura suggested that the monument could be the remains of a structure built during the last ice age, when sea levels were significantly lower, and the area around Yonaguni would have been dry land. If this interpretation were correct, the structure would be extraordinary, potentially dating to over 10,000 years ago, which would make it one of the oldest known monumental structures on Earth. Other scientists disagree. Robert Schoch, a geologist at Boston University, has argued that the formations are entirely natural, the product of tectonic uplift in the fracturing patterns of the local sandstone, which tends to break along flat plains and right angles due to its layered structure. The steps, in Schoch's analysis, are natural terracing caused by differential erosion. The right angles reflect the rock's crystalline structure, not human craftsmanship. The overall appearance of the monument is striking, he acknowledged, but the geology of the region can explain it without invoking human construction. The debate has not been resolved. Both interpretations have supporters. Neither side has produced evidence definitive enough to settle the question. Part of the difficulty is that the formations exist underwater, which makes detailed geological study more complex than it would be on land. Part of the difficulty is that the difference between a naturally fractured sandstone terrace and a roughly hewn stone step at a distance of 10,000 or more years of erosion and biological incrustation may be impossible to determine with certainty. The Yonaguni monument sits on the ocean floor and holds its ambiguity with the patience of stone. It does not confirm or deny. It simply persists, looking exactly like what it has always looked like, while humans argue about what they are seeing. I find something appealing about that ambiguity, honestly. Not because I want the answer to remain unknown, but because the ambiguity itself reveals something about how the mind works when confronted with patterns at the boundary between the natural and the artificial. The human brain is extraordinary at detecting patterns in faces and order, even where none exists. We see constellations in random arrangements of stars. We see faces in clouds and power outlets in the fronts of cars. The tendency to perceive intentional design in natural formations is not a flaw of cognition. It is one of cognition's defining features. The question, in the case of Yonaguni, is whether the pattern the eye detects is genuinely there, or whether the eye is doing what eyes always do, finding meaning in noise. And the ocean, which has been rearranging stone and sediment for millions of years, is very good at producing noise that looks like meaning. In 2011, in the Baltic Sea, between Sweden and Finland, a Swedish ocean exploration team called Ocean X made a sonar discovery that attracted global attention. At a depth of roughly 87 meters, they detected an object on the seabed that was roughly 60 meters in diameter, oval-shaped, and described in their sonar readings as having a stone-like or metallic surface that was unusual for underwater formations. The object appeared to be sitting on a raised pillar, and there were marks on the seabed leading away from it that resembled tracks or skid marks, as though the object had moved along the bottom before coming to rest. The Baltic Sea Anomaly, as it was immediately christened by the media and the internet, became one of the most discussed ocean mysteries of the 2000s. The shape, of the object, in the low-resolution sonar images, bore a passing resemblance to the Millennium Falcon from Star Wars, a detail that the internet seized upon with predictable enthusiasm. Theories about the anomaly range from a crashed alien spacecraft to a secret World War II weapon to a natural geological formation. Subsequent dives by the Ocean X team and other researchers produced additional information, but no definitive identification. The object's surface was described as rock-like. Samples taken from it appeared to be natural stone, possibly granite. Some researchers suggested it could be a glacial deposit, a large rock or cluster of rocks deposited on the seabed by retreating ice during the last ice age. Others noted that the shape and surface characteristics were unusual for a glacial deposit and warranted further investigation. As of the most recent examinations, the Baltic Sea anomaly remains unexplained in the sense that no single hypothesis has been confirmed. It sits on the floor of the Baltic Sea, 60 meters across, looking like exactly what it looks like, inviting interpretation and resisting confirmation. The ocean floor, as we discussed at the beginning of this long night, is mostly unmapped, and the part that has been mapped continues to produce surprises. Not all of them are mysterious, some are simply beautiful. In waters off the coast of Japan, divers began noticing intricate circular patterns on the sandy seabed, elaborate designs that looked like underwater crop circles. The patterns were too regular, too symmetrical, too complex to be accidental. They were clearly the product of intention. But whose intention? The answer when it arrived was one of those discoveries that is more interesting than most of the mysteries it resolved. The circles were being made by a species of pufferfish. Male pufferfish, each only a few inches long, were spending days creating elaborate circular patterns on the seabed by swimming in the tight, rhythmic paths and flapping their fins against the sand. The completed circles could be several feet in diameter, with radiating ridges and valleys, and a smooth central area where the female would eventually lay her eggs if she found the display sufficiently impressive. The pufferfish were building architecture, not in the metaphorical sense, in the literal sense. They were constructing three-dimensional structures from sand using only their bodies and their time, structures whose complexity rivaled anything a human sculptor might produce at the same scale, and they were doing it for the same reason that many human architects do what they do, to attract a mate. The discovery was made in 2012 by a team of Japanese researchers who had been puzzling over the circles for years. The species responsible, Torquigina, had not been previously known to science. It was new. The circles were new. The behaviour was new. And the fact that it had been happening on the ocean floor, undiscovered for presumably millions of years, while humans were busy charting the surface and arguing about sea monsters, is a fact that carries its own quiet weight. There is another kind of ocean structure that is neither geological nor architectural, but behavioural. A place in the open Pacific Ocean, roughly halfway between the coast of California and Hawaii, where great white sharks go. Not a few of them, many of them. Every year, great whites from the eastern Pacific leave the coastal waters, where they hunt seals and travel thousands of miles to a region of open ocean that, by every surface measure, is empty. No islands, no seamounts rising to the surface, no obvious food source, no visible reason for a massive apex predator to travel that far from the coast. Scientists who first documented the migration called the destination the White Shark Cafe. The name was slightly facetious, but the mystery was genuine. For decades, researchers tracked great whites using satellite tags and found, repeatedly, that the sharks made this long journey to a seemingly featureless patch of open ocean and then engaged in unusual behaviour. They performed deep dives, plunging to depths of hundreds of metres, and then surfacing rapidly, over and over, in a pattern that did not match any known foraging or migratory behaviour. Were they feeding on something at depth that surface observations could not detect? Were they engaged in a mating ritual? Were they navigating by some sense that human instruments could not measure? More recent research has suggested that the White Shark Cafe may sit above a productive deep-sea ecosystem, a layer of the mesopelagic zone rich in squid and small fish that migrate vertically through the water column every night, rising toward the surface to feed and descending during the day to avoid predators. The sharks may be exploiting this vertical migration, diving to intercept the prey as it moves, but the explanation remains incomplete. The specific reason why this particular patch of ocean attracts great whites from thousands of miles away, and why they behave the way they do when they get there, is still not fully understood. The ocean builds structures from heat as well, hydrothermal vents where superheated water rich in dissolved minerals erupts from the seafloor along mid-ocean ridges and at tectonic boundaries, create some of the most remarkable ecosystems on the planet. The vents were not discovered until 1977, when researchers aboard the submersible Alvin found them on the Galapagos Rift in the eastern Pacific. What they found around the vents defied the assumption that all life on Earth ultimately depends on sunlight. The vent ecosystems were powered not by photosynthesis, but by chemosynthesis. Bacteria at the base of the food chain were deriving energy from the chemical reactions between the hot, mineral-rich water and the surrounding seawater, producing organic matter without any input from the sun. Giant tube worms, some over 6 feet long, clustered around the vents, harbouring the chemosynthetic bacteria in their bodies in a symbiotic relationship that had no precedent in known biology. Blind shrimp, white crabs, dense communities of organisms thriving in conditions that should have been lethal, in temperatures exceeding 300 degrees Celsius in the immediate vicinity of the vent, in total darkness, in pressure that would kill any unprotected surface organism instantly. The discovery of hydrothermal vent ecosystems changed the scientific understanding of what life requires. Before 1977, sunlight was considered a prerequisite. After 1977, it was clear that life could sustain itself entirely on chemical energy from the Earth's interior. This had implications far beyond marine biology. If life could exist in the lightless, crushing, toxic environment around a deep-sea hydrothermal vent, then life might also exist in similar environments on other worlds. The oceans beneath the ice of Jupiter's moon, Europa, or Saturn's moon Enceladus, could harbour hydrothermal systems similar to those on Earth's seafloor. The discovery of vent life did not prove that extraterrestrial life exists, but it dramatically expanded the range of conditions under which life is considered possible. The vents themselves are structures of a kind. They build chimneys, sometimes called black smokers, towers of precipitated minerals that can grow to heights of over 60 feet, erupting superheated mineral dark water from their tops in plumes that look like smoke rising from a factory chimney. The chimneys grow, collapse and regrow on timescales of years to decades, and the ecosystems around them shift with them, colonizing new vents as they open and dying off as old vents cool and close. The vent fields are dynamic, temporary structures built by the Earth's internal heat, and the life around them is adapted to impermanence in a way that most surface ecosystems are not. The organisms of a hydrothermal vent community do not have the luxury of geological stability. Their home is a hot spot in the crust that could cool or shift or close at any time, and they thrive anyway, for as long as the heat lasts, in defiance of every assumption about what life requires. And then there is the Earth's hum. This is not strictly speaking an ocean structure, but it is a phenomenon detected through the ocean and intimately connected to it. The Earth produces a persistent, extremely low frequency vibration, a kind of background oscillation that rings continuously at frequencies between 2 and 7 millihertz, far below the range of human hearing. The hum was first confirmed in the late 1990s using seismometers, and its source has been debated ever since. The leading hypothesis is that the hum is generated by the interaction of ocean waves with the seafloor, specifically by infragravity waves, very long-period ocean waves that transfer energy to the solid Earth when they interact with the continental shelves and the ocean floor, causing the planet to vibrate at frequencies so low they qualify as seismic rather than acoustic. The Earth is humming. The ocean is making it hum. The planet's solid body resonates with the energy of its own waves, and the result is a vibration so faint and so low-pitched that no human ear can detect it, but that seismometers on every continent have confirmed. You are lying on a planet that is being gently shaken by its own ocean, continuously, and neither you nor anyone else can feel it. It is another of those facts about the relationship between the body and the planet that the senses cannot access, but the instruments confirm. The hum is there. It has always been there. It will continue as long as there are oceans and a solid Earth for the oceans to press against. The Sargasso Sea, which appeared in the previous section in the context of vanishings and unease, deserves another moment here in the context of structures because it is, in its own way, a structure that the ocean built from nothing solid. The Sargasso Sea has no coastline. It is the only sea on Earth defined entirely by ocean currents rather than by land. The North Atlantic subtropical gyre, a system of rotating currents, creates a region of relatively calm, warm water in the middle of the Atlantic, and within this region, the Sargassum seaweed that gives the sea its name accumulates and thrives. The sea is a structure of water and weed and current, with no fixed boundary, no permanent border, shifting and reforming with the movements of the gyre. Within the Sargasso Sea, the mats of floating sargassum create their own ecosystems. Small fish hide among the fronds. Crabs and shrimp and nudibranchs live their entire lives on the weed. Juvenile sea turtles use the sargassum mats as nursery habitat. The floating structure, insubstantial as it appears, supports a community of organisms that depends on it entirely. The Sargasso Sea is a place that the ocean maintains through the continuous operation of its currents, a habitat built from motion rather than from matter, a structure that would cease to exist the moment the current stopped rotating. In 2024, through the Seabed 2030 mapping effort and the work of NOAA Ocean Exploration, scientists characterized the largest known deep-sea coral reef habitat, spanning over 6.4 million acres on the Blake Plateau off the southeast coast of the United States, 6.4 million acres of deep-sea coral, sitting on the ocean floor at depth, in cold water, in darkness, building itself up over thousands of years, one calcium carbonate polyp at a time. The coral reef is a structure built by organisms at a scale that rivals anything humans have constructed, and it was only recently discovered because the ocean floor where it sits had only recently been mapped. The ocean builds. That is the thing worth holding here. Not just in the sense that geological processes create underwater mountains and trenches over millions of years, though they do, but in the sense that living organisms in the ocean create structures. Pufferfish create sand circles, coral polyps create reefs the size of national parks, sargassum mats create floating ecosystems defined by current rather than by land. The ocean structures are not ruins. They are not remnants of a past civilization. They are ongoing acts of construction performed by organisms that have been building for far longer than humanity has existed, at scales that we are only beginning to map and understand. The Yonaguni monument may be natural, it may be man-made. The Baltic Sea anomaly may be a glacial deposit, it may be something else. The pufferfish circles are definitively the work of a living organism, and they are more beautiful than most of what humans build. The deep-sea coral reefs are the work of millions of tiny animals, and they cover an area larger than many countries. The ocean floor is not a barren plain. It is a landscape, inhabited, constructed, shaped by the same forces that shape landscapes on land, plus forces that have no equivalent on land, and most of it remains unseen. Tonight, somewhere on the ocean floor, a pufferfish is building a circle. A coral polyp is adding a microscopic layer to a reef that has been growing for centuries. A rock formation off the coast of Japan is looking like something it may or may not be. An oval-shaped object in the Baltic Sea is sitting in the cold water at 87 meters, being whatever it is, unbothered by the arguments happening on the surface about what it might be. The ocean structures do not need to be understood to continue existing. They were there before anyone asked about them. They will be there after the questions have moved on to other things. And now, after all of this, after the unmapped floor, and the crushing trench and the sounds that travel thousands of miles, and the light that comes from the dark, and the creatures that science barely knows, and the predators that have reshaped a coastline, and the ships that vanished and the structures that resist explanation, there is one more thing, one more connection between the ocean and the body you are lying in. One more thread, the last one, and it is closer than any of the others. The human body is approximately 60% water by mass. You have heard this before. It is one of those facts that circulates through health articles and science classes and motivational posters about staying hydrated. 60%, more than half. The majority of the physical substance of a human being is water, but stay with it longer than you usually do. Not as a health fact, as a chemical fact, as a fact about what you are made of, at the molecular level right now, tonight, in this room. The water in your body is not a separate thing that you happen to contain. It is the medium in which your biology operates. Your cells do not sit in water the way objects sit in a container. Your cells are made of water, structured by it, held in shape by its interactions with the proteins and membranes, and dissolved ions that make cellular life possible. The chemical reactions that keep you alive, every single one, from the firing of a nerve impulse to the contraction of a muscle fibre, to the breakdown of food into usable energy, take place in water. Without it, the chemistry stops. Without the water, there is no biology. There is just a collection of dry molecules in a shape that used to be a person. The water in your body was not created for you. It was not manufactured by your mother's body during pregnancy, conjured from nothing to fill the space inside a developing human. It was inherited. It came from somewhere. The specific water molecules that are currently participating in the chemistry of your brain, carrying the electrochemical signals that allow you to process language, to form thoughts, to feel the weight of your own head against the pillow, those molecules have a history. they have been places. Water on Earth is old. The total amount of water on the planet has remained roughly constant for billions of years. The water cycle, evaporation and condensation and precipitation and runoff and evaporation again, moves water through different phases and locations, but it does not create or destroy it in any meaningful quantity. The water in your body has been through this cycle many times. It has been in clouds, it has been in rivers, it has been in glaciers, it has been in soil, it has been in the tissues of other living organisms. And at some point in its history, some of the water currently inside you was in the ocean. This is not a metaphor. The water cycle connects every body of water on the planet, and the ocean is the largest reservoir. Roughly 97% of the Earth's water is in the ocean. The water that evaporates from the ocean surface rises into the atmosphere, forms clouds, falls as rain somewhere on land, flows through rivers and aquifers, and eventually returns to the ocean, where the cycle begins again. The residence time, the average amount of time a water molecule spends in the ocean before evaporating and entering the atmosphere, is approximately 3,000 years. Every water molecule in the ocean will eventually leave it, travel through the atmosphere, fall on land, and return. And every water molecule on land has, at some point, been in the ocean. The water in your blood has been in the ocean, not all of it at the same time, not recently necessarily, but over the long history of the water cycle, which has been running for as long as there has been liquid water on Earth. The molecules that make up your body's water have cycled through the ocean, through the atmosphere, through rain and rivers and groundwater, and into the biological systems that eventually produced you. You contain recycled ocean water. It is in your cells, it is in your joints, it is in the fluid that cushions your brain inside your skull, it is in the tears your eyes produce to keep themselves clean while you sleep. There is something else about the water in your body that connects you to the ocean more directly than the water cycle alone. The salinity of human blood, the concentration of dissolved salts, is remarkably close to the salinity of the ancient ocean in which complex life first evolved. Not the modern ocean, which is slightly saltier. The ancient ocean, the Precambrian ocean, the body of water in which the earliest multicellular organisms developed the circulatory systems that would eventually become blood. The similarity is probably not coincidence. The leading interpretation is that when early organisms developed internal fluid systems, those systems were filled with the ambient water of the environment, which was seawater. The salt concentration of that seawater became the default salt concentration of biological fluids, and as organisms evolved and moved into different environments, they maintained that internal salinity because their biochemistry depended on it. Your blood is, in a very real chemical sense, a sample of the ancient ocean, maintained at the concentration that your distant ancestors evolved in, carried forward through hundreds of millions of years of evolution, still sloshing through your veins tonight, still doing the same basic job it did when the first fish developed a circulatory system. You carry an internal ocean, not as a poetic image, as a physiological fact. The salt water in your body is a direct chemical descendant of the salt water in which life itself developed. The ocean is not something external to you. It is something you contain, something you are made of, something that runs through you in the most literal cardiovascular sense possible, and the minerals in your body have ocean connections as well. The calcium in your bones, the sodium and potassium that drive your nerve impulses, the magnesium that participates in hundreds of enzymatic reactions, all of these elements cycle through the ocean as part of the geochemical systems that move material between the crust, the water, the atmosphere, and the biosphere. The ocean is the planet's central chemical processing system, dissolving minerals from rock, distributing them through currents, making them available to organisms that incorporate them into their bodies. Your body's mineral composition reflects, however indirectly, the geochemistry of the ocean that provided the raw materials. There is a deeper layer to this, And it involves not just the chemistry of your body, but the history of how your body came to exist at all. Every vertebrate animal on land, every mammal, every reptile, every bird, every amphibian descended from organisms that lived in the ocean. Life began in the ocean, not on land. The ocean was the first home of every lineage of complex life on Earth. The transition from sea to land happened gradually, over hundreds of millions of years, through intermediate forms that are preserved in the fossil record. Animals like Tiktaalik, a roughly 375 million year old fish with rudimentary limbs and a neck, a creature that lived in shallow water and could push itself along the bottom, a body plan that sits almost exactly at the transition between fish and tetrapod, between water life and land life. Your body carries the architectural traces of that transition. The bones in your hand, the radius and ulna, and the carpals and metacarpals and phalanges are the same bones, modified over 375 million years, that form the pectoral fins of the fish that first ventured onto land. The basic plan is the same. One bone, two bones, many bones, digits. You can trace the same pattern from a human hand to a whale flipper to a bat wing to the leg of a horse. All of them are variations on the limb that first evolved in a fish that was learning to walk on the bottom of a shallow sea. Your hands are modified fish fins. That is not a metaphor. It is developmental biology. The lungs you are breathing with right now evolved from swim bladders, gas-filled organs that fish use to control their buoyancy in the water column. The swim bladder and the lung are the same organ, adapted for different purposes. In water, the organ holds gas to keep the fish at a stable depth. On land, the organ exchanges gas with the atmosphere to provide oxygen to the blood. Your respiratory system is a repurposed piece of fish anatomy. Every breath you take tonight is being processed by an organ whose original function was to help a fish float at the right depth in the ocean. The inner ear, the part of your body that allows you to hear, that gives you your sense of balance, that tells you which way is up when your eyes are closed, evolved from a sensory organ in early fish called the lateral line, a system of pressure-sensitive cells arranged along the body that allowed fish to detect vibrations and movements in the surrounding water. The lateral line was an ocean sense organ. It detected the ocean's motions, and when the descendants of those fish moved onto land, the lateral line was internalized, modified, and became the inner ear. You hear with a modified ocean sensor. The organ that detects sound waves in the air is the same organ, evolved and refined over hundreds of millions of years, that once detected pressure waves in water. You are not a land animal that happens to have a connection to the ocean. You are an ocean animal that moved to land, carrying the ocean's chemistry in your blood, the ocean's architecture in your bones, the ocean's sensory apparatus in your ears, and the ocean's gas management system in your lungs. The land is where you live, the ocean is where you come from, and the traces of that origin are not hidden. They are the most fundamental features of your body, so basic that you do not notice them, the way you do not notice the walls of the room you have lived in long enough to stop seeing. And the ocean continues to sustain you even now, even on land, even in this room, even tonight. The phytoplankton living in the surface layer of the world's oceans produce by most estimates between 50 and 80% of the oxygen in the Earth's atmosphere. Not all of it. Land plants contribute significantly, but the ocean's microscopic photosynthetic organisms, single-celled creatures floating in the sunlit upper layers of every ocean on the planet, are responsible for the majority of the oxygen production on Earth. Every other breath you take, roughly speaking, contains oxygen that was produced by a marine organism. The phytoplankton do not produce this oxygen for you. They produce it as a byproduct of photosynthesis, the same way land plants do, converting carbon dioxide and water into sugar and oxygen using sunlight as an energy source. The oxygen is waste, from the phytoplankton's perspective. It is the exhaled byproduct of their metabolism, and it drifts from the surface of the ocean into the atmosphere, where it mixes with the oxygen produced by forests and grasslands and all the other photosynthetic organisms on land, and eventually reaches this room, where it enters your lungs and binds to the hemoglobin in your blood and is carried to every cell in your body to drive the chemical reactions that keep you alive. You are breathing ocean air, not exclusively, but substantially. The oxygen in this room has ocean origins. The water in your body has ocean origins. The salt in your blood has ocean origins. The bones in your hands have ocean origins. The organs in your chest have ocean origins. The senses in your ears have ocean origins. You are, in the most comprehensive biological sense, a piece of the ocean that learned to walk on land and then forgot where it came from. This brings the night's thinking to a place that is difficult to articulate neatly, and I want to try to say it plainly, rather than making it sound tidier than it is. The ocean is not separate from you. The distance between your body and the ocean, the physical distance, the geographical distance, the conceptual distance that makes the ocean feel like a place you go to, rather than a place you are from. That distance is real in the everyday sense. You are here, in this room, on land, surrounded by air, and the ocean is somewhere else, miles or hundreds of miles away, behind a coastline below a surface you cannot see through. In the ordinary experience of your life, the ocean is elsewhere. But in the chemical and biological and evolutionary sense, the ocean is here. It is in you. The water in your cells is recycled ocean water. The salt in your blood is the concentration of an ancient sea. The minerals in your bones have cycled through ocean water as part of the geological processes that have been running for billions of years. The oxygen you are breathing was produced, in significant part, by photosynthetic organisms in the ocean, phytoplankton, that generate roughly half of the world's oxygen supply. The air you are drawing into your lungs right now contains oxygen molecules that were released by marine organisms in the surface layer of an ocean you may never have visited. You are a land-dwelling organism made substantially of ocean materials, breathing ocean-produced air, running on the chemistry of an ancient sea. The separation between you and the ocean is a separation of location, not of substance. You are in this room, and the ocean is out there, but the boundary between the two is more permeable than it appears. The ocean is in the room with you. It is in your blood. It is in your breath. It is in the water that makes up the majority of your physical mass. This is not a new idea. The connection between human bodies and the ocean has been noted by scientists and poets for as long as people have been thinking about such things. But it tends to be stated as a pleasant fact, a nice piece of trivia, and then set aside. I want to hold it a little longer tonight. Not because it leads to a conclusion or a call to action or a lesson, but because it changes, slightly, what it means to think about the ocean as a place full of mysteries. The ocean's mysteries are not the mysteries of something alien. They are the mysteries of something you are connected to, at the molecular level. The unmapped floor, the crushing trench, the sounds that travel thousands of miles, the light that glows in the dark, the creatures that have never been seen, the predators that reshape coastlines, the ships that vanish, the structures that resist explanation. All of these mysteries exist in a body of water that is chemically related to the body you are lying in. The ocean is not a foreign country. It is the country you came from, in the deepest evolutionary sense, and you carry your citizenship in your blood. The room is quiet now, or quiet enough. The sounds of the house have settled into their overnight pattern. Whatever machine was humming has either stopped, or become so constant that the auditory system has filed it under background and stopped reporting. The body is doing what it does at this hour. The slow relaxation of muscles that have been holding posture all day, the gradual deepening of breath, the quiet withdrawal of attention from the external world into the internal one. Sleep is approaching, or it will approach in its own time, at its own pace, without needing to be summoned. Outside the window or somewhere beyond the walls, the night is doing what it does. The part of the earth you are on is facing away from the sun, and the darkness is not really darkness at all, but the shadow of the planet itself, cast into space, and you are lying inside that shadow, on the surface of a world that is mostly water, in a body that is mostly water, breathing air that was partly made by water, carrying in your veins the salinity of a sea that existed before anything on Earth had veins. The ocean will still be there in the morning. Its mysteries will still be in it. The Mariana Trench will still be dark. The bloop has been explained, but the upsweep continues, cycling through the Pacific on a schedule that nobody has fully accounted for. The bioluminescent organisms will still be glowing in the deep, 540 million years into a habit that started before anything could see them doing it. The giant squid and the colossal squid will be moving through the mesopelagic and bathypelagic zones, in bodies that no camera has adequately documented, doing whatever it is they do when they are not being watched, which is almost always. Port and starboard will be somewhere off the South African coast, or further afield, carrying the skill of shark liver extraction in their brains, a technique that has altered the ecology of a coastline and that may or may not spread to other orcas in the years to come. The Mary Celeste's crew will still be missing. The USS Cyclops will still be unfound. The Yonaguni Monument will still be sitting in the shallow water of Japan, looking like what it looks like, which is either a natural formation or the remnant of something built by human hands 10,000 years ago, and the ocean will not settle the argument. None of this asks anything of you tonight. None of it requires you to hold it, or solve it, or feel anything in particular about it. The ocean's mysteries are patient in the way that all large old things are patient. They were there before anyone asked about them. They will be there after the asking has moved on. They do not need resolution. They do not need attention. They just continue in the dark, in the pressure, in the cold, in the salt water that is their medium and your inheritance. The body you are in is mostly water. The planet you are on is mostly ocean. The ocean you live beside or far from or have never seen is mostly unknown, and the unknown part is not a failure or a problem or a challenge to be overcome on any particular timeline. It is just the current state of the relationship between a species and the body of water it emerged from. The relationship is young, the ocean is old, there is time. And maybe that is the thing about ocean mysteries that separates them from other kinds of mysteries. A murder mystery has a solution. A mathematical conjecture has a proof or a disproof. A medical mystery has a diagnosis. These are mysteries with endings, questions that resolve into answers, and the resolution is the point. The ocean's mysteries are different. Some of them will be solved, eventually. The upsweep will likely be traced to a specific geological source as monitoring improves. The giant squid will eventually be filmed in its natural habitat, doing whatever it normally does. The unmapped 73% of the ocean floor will be mapped, year by year, sonar pass by sonar pass, until the blank spaces on the chart are filled. But some of the mysteries will simply give way to deeper mysteries. Every expedition that discovers 100 new species also discovers 100 new questions. Every new depth reached reveals conditions that expand the range of what we thought possible. The ocean does not run out of mystery the way a puzzle runs out of pieces. It generates mystery at the same rate it generates answers, and the net balance stays roughly the same. The ocean is not a problem to be solved. It is a relationship to be continued, and the continuation has no endpoint, which is not a frustrating thought if you hold it gently enough. It is simply the truth about living on a planet whose most prominent feature is deeper, stranger, older and more alive than you will ever fully know. The weight of the body against whatever is holding it. The sound of the room being the room. The specific heaviness of late night. The kind that collects in the eyelids and in the shoulders, and in the particular quality of attention that has stopped reaching forward and is now just resting where it is. That is where this began. That is where it ends. In a room. In a body. On a planet that is mostly water. Inside a mystery that is mostly unsolved. Resting. The ocean will still be there in the morning. It will be there for a very long time. You do not have to do anything with that. You do not have to hold it or remember it or carry it anywhere. It is already holding you. The water in your cells, the salt in your blood, the oxygen in your lungs, The ocean has been here the whole time, closer than you thought, quieter than you expected, larger than you can hold in a single night's thinking, and that is fine. That is enough. That is what this kind of thinking is for, not to solve, not to conclude, but to sit with, for however long the night allows, and then to set down gently, and let rest. The ocean will still be there in the morning. If this found you somewhere quiet, and something in it settled, a subscribe helps more people find their way here. And if you know someone who thinks best when the world gets a little bigger and a little stranger, send this their way. That is how this kind of work travels.